know the experts sitting next to you. Because in the end, AU isn't about technology. It's about you, the creators, the builders, the makers, the problem solvers. So thank you for being here at AU and bringing your unique experience, perspective, and creativity. Together, we're going to make something incredible. Have a great AU.
As you heard there from Carl, it's all about introducing and sharing. So with that in mind, we're going to try and make this as interactive as possible. Hashtag AUME2016. Make sure you use the hashtag throughout the day to interact and share. Autodesk story, though, is not just about software. It's also about human ingenuity and the drive that all of us have within us to improve the reality around us, not just for ourselves, but for everyone else in the world. That reality is, I think you'll all agree, radically changing at the moment. Why is it changing? It's changing thanks to new technologies that you, hopefully, will experience today, both here in the main auditorium and outside in the pre-function exhibition area as well. Perhaps it's going to be the first time for you, perhaps not. We hope to leave you with, well, renewed inspiration in how the way things are designed, they're made, and they're used is being profoundly altered at the moment. But if you've ever, if you've ever driven a high-performance vehicle, a high-performance car, if ever you've looked up and admired a towering skyscraper, and there are enough of those around here, if ever you've used your smartphone, you probably are using it at this very moment in time, or watched even a great film, as we've seen just a few elements and examples of there, the chances are that you're already halfway there. You've already experienced what millions of Autodesk customers are doing with that all-important human ingenuity. I think it's fair to say that with Autodesk, you have the power to make anything. ladies and gents, let's hear it one more time for our Stomp Urban Artists! Our thank you to the Stomp Urban Artists for their time this morning. We'll give you a few moments to take that in because we will be asking you to do exactly the same in round about an hour's time, okay? So we'll let you break out for a cup of coffee and a croissant, and then we'll get back and try and get you up here on stage. No, big thank you to them. Just showing you what is possible. You can create anything from almost nothing as well and turn together an extraordinary performance like that. Incredible little start. Hopefully that's woken you up to proceedings this morning. As I said, we try and get you interacting with proceedings as we've garnered some experts from all corners of the globe who've come here to speak to you today. My name's Tom Urquhart. I am honored to be your host here today as we explore disruptive technologies that are changing the way that we design, that we make things, and we hear expert insights, as I mentioned there, on how these technological advances will shape the very future, the very fabrication of building our respective nations. We start with an opening welcome, an individual who's come here to welcome each and every one of you, who've helped to get everyone here in this room here today. We're going to be hearing from the country manager at Autodesk Middle East, who will be setting the tone for the day. Welcome you individually, but also getting the ball rolling. So without further ado, please, ladies and gentlemen, welcome to the stage, country manager at Autodesk Middle East. It is my pleasure to welcome Mr. Tony Wujec to the stage. Tony.
Thank you, Tom. Thanks, Tom, for the introduction. Good morning, everyone. As country manager for the Gulf countries and on behalf of Autodesk, it is my honor and pleasure to welcome our government officials, customers, students, faculty, our speakers who traveled far and wide to be with us today. And last but not least, the Autodesk executives who continue to invest in our regions. What you will experience here today has been designed to inspire you, to help you to understand how the technologies of today and tomorrow will empower you to make your future, to make anything. It is with a huge pride that this region has been entrusted with globally acclaimed projects, such as the World Expo 2020, the 2022 Qatar World Cup, and the surrounding infrastructure to support them. Add to that the ambitious smart city initiatives that our leaders have envisioned and invested in. The vision of His Highness Sheikh Mohammed bin Rashid Al Maktoum, the future of making things doesn't seem far away at all. But today, at our Autodesk University Middle East, you will learn how to embrace future technologies in order to build your offerings as a company and your own career within it. Autodesk University is only one medium through which we deliver this thought leadership initiative. But one has grown from a humble user group meeting in San Francisco over 20 years ago to become a global network of 15 cities and a record of 25,000 delegates, of which you are part today. So give yourselves a round of applause. Without the incredible support from our sponsors, today would not be the experience that you see before you. So it is with gratitude that I recognize our supporters here today. HP, Microsoft, Dell, Leica Geosystem, MSI, and Ultimaker, who have all chosen to associate their brand with our vision to the future. And also, our channel partners, who have supported the event today. We thank you for your dedication to Autodesk brand. Now you will gain much value from today's proceedings. It is my duty and honor to now welcome to the stage our very close colleague and mentor, a big advocate and supporter for the Middle East region, Callan Carpenter, Vice President of Global Named Account at Autodesk.
I don't know about you, but that dance-off that was going on here a moment ago looked like some project architect contractor meetings I've been in before. Very similar. Well, good morning. Good morning. There you go. You have to be awake after that introduction. My name is Callan Carpenter, and I'm very pleased to welcome you to AU Middle East, the first AU Middle East here in Dubai. I have the extreme pleasure and privilege of traveling around the world and meeting with customers in every industry that we serve in countries around the globe. And this is one of my favorite places to visit. Been coming here for some number of years now. And the reason it's one of my favorite places to visit is because there is such an audacity of vision here in the Middle East, and particularly in the Gulf region, the GCC region. Nothing is impossible in the minds of the people who live in this area. This is the countries that build islands, that build the world's tallest skyscrapers, who have no limit to their vision. And so it is a great privilege to be here, but it's also a little bit of a challenge because my topic today is the future of making things. Talking about the future is a little bit risky. First of all, by definition, it hasn't happened yet. But I think more importantly, talking about the future is risky because it has a habit of getting here and becoming the present much faster than we expect. In fact, technology has been growing exponentially since at least the beginning of the 19th century and the dawn of the Industrial Revolution. And as the famous author William Gibson said, the future is already here, it's just not very evenly distributed. But having said all that, we're going to talk today about Autodesk's view of the future of making things. What kind of things? Well, essentially everything. Whether we're talking about great civil engineering projects, giant skyscrapers, automobiles, entertainment, movies. All of these industries are going through an era of disruption and innovation like none that has ever come before. These sources of disruption come from many different things. They come from technological innovations. They come from changes in demographics. They come from the world becoming a smaller place every single day. And so today, for the next 45 minutes to an hour, myself and my colleague Tom, who's going to join me or come right after I'm done here, we're going to talk about what we see as the most important disruptors in these industries, the most important ideas that we all need to be aware of as we manage our own businesses, as we plan for the future of our companies and of our countries. Now, as I talk about these things, keep in mind that there are 4 big areas of disruption that we like to talk about at Autodesk. First of all, in the way things are designed. And I'm going to give you a number of examples of how design is changing radically in ways not even conceived of maybe 5 or 10 years ago. We're going to talk about how things are actually produced, the making and the building of the things that we see around us. And we're going to talk about the products themselves and how they're evolving, this era of connectedness that Tom mentioned in his introduction. The fact that products are so much more than the dead artifacts they used to be. They're now connected, they get smart, they become better over time, and they generate an experience, and it's that experience that we as engineers and designers are creating for our customers. But also the nature of demand is changing. Today's generation has a different expectation about the products that they buy, the buildings that they live in, the automobiles that they drive. We could talk about the Gen Xers or Ys or Zs or the digital natives, but all of these folks are thinking about the world perhaps differently than those in my generation. We think about the environmental impact of what we buy. We think about how was it sourced and what's going to happen to it after I'm done using it. They think about how easy is it to use. Nobody picks up a manual to learn how to use their phone anymore. They expect it to be easy. But one trend that affects all industries, I just want to touch on for a moment, is this idea that things will be built for me. That buildings and automobiles and movies and games and everything else I buy will somehow be customized to me and my needs. Mass customization. Here's a very simple example. A company called Normal, based in New York. They sell earbuds for iPhones and so forth. They have an app. You load that app onto your phone, you take a couple of pictures of your ear, you send those photographs up to Normal, they create a 3D model of your ear, and they custom 3D print a set of earbuds precisely that fits you, okay? Now, you can see the same trend happening in automobiles, you can see it happening in architecture. The problem for all of us as business people is that customers want the bespoke, but they're not willing to pay for it. So how do we rise to this occasion? All right. So, design, production, the products themselves. These are the areas that we're going to talk about today in terms of disruption. And I'm going to reformulate the problem in a slightly different way. Every product, every building, every piece of infrastructure, every movie ever made has a very straightforward life cycle, simplified here. It gets designed, it gets produced in some way, and it gets used or experienced by the consumer. I'm going to start out talking about disruptions in design. This is an area that's incredibly exciting and moving at a tremendous pace today. And the first thing I want to talk about is the cloud. Fundamentally, the cloud is enabling an era of computational access that we have not seen ever in the history of mankind. Autodesk was born 35 years ago at the beginning of the PC era, when the founders recognized that the PC was a step function, a quantum leap in the equation of the cost for computing. Moving off of mainframes, moving off of mini computers onto PCs meant millions of more people than ever before could have access to computing, and that's what gave rise to Autodesk. Today we see a very similar disruption happening, and it's the cloud, and is yet another order of magnitude change in the cost of computing and the democratization of technology. What are we going to do with this? Well, there are many things we're going to do with this technology. When you think about the fact that a CPU hour in the cloud costs less than a cup of coffee and is getting cheaper every single day, the sky is truly the limit. Let's talk about collaboration. Collaboration is something that the cloud is uniquely designed to enable. More than ever before, designers, engineers, manufacturers are located geographically all over the globe. You can't count on everyone on the team being in the same country, much less the same room anymore. The cloud enables us to take advantage of expertise wherever it may be in the world. And here's a great example. This is a company called CanTouch. CanTouch were experts in 3D printing in Russia, and they were inspired by a need, the need to provide prosthetic arms and limbs for children in Russia. And not just cosmetic prosthetics, but prosthetics that actually worked, that would allow a child to grasp a ball or a toy or what have you. So they got together with another company who were experts, WEAS, experts in robotics. And even though one was located in Moscow and the other one in St. Petersburg, they were able to collaborate and produce a solution that allows children to now have low-cost, articulating, functioning prosthetic limbs. By the way, before they did this, a similar type limb might cost 100,000 rubles. With their solution, it's now 15,000 rubles. They've made a difference in their world, and they did it through collaboration. Let me talk about a different kind of collaboration. Ford Motor Company, like all automobile companies today, is undergoing tremendous disruption. Electric powertrains, autonomous vehicles, even a change in the notion of automobile ownership with the rise of Uber and similar type services. But one of the challenges that all the automotive companies have to face is how to collaborate between different disciplines, and they've had this challenge all their lives. Design, engineering, manufacturing. 3 groups within every automotive company that see the world through very different eyes. Well, look at the innovative way that this gal, Elizabeth Barron, has found to get collaboration between these different disciplines. Elizabeth founded the Virtual and Augmented Reality Lab 20 years ago at Ford, and I'm going to let her tell her story for you.
We're here in the virtual space of the Product Development Center in Dearborn, Michigan. Here in the virtual lab, we assess high-definition renderings of the vehicle to overall improve quality and appeal of the vehicle.
In this space is a full-size virtual vehicle that we can evaluate for many different aspects of engineering and design and look at it from the customer's perspective.
We put the head-mounted display over your eyes so that you have computer screens in front of your eyes effectively, and then we track where those are relative to this space, and then we put the CAD information over your eyes, and then we're tracking where you are relative to that CAD information, so you can walk around and interact with the entire vehicle.
And then we give you tools which are very similar to what you have in the physical world to look at the car and evaluate it for quality.
So the biggest benefit is the ability to have a realistic vehicle much, much sooner in the product development phase.
We can represent them in our software instantly to show many of the different possible combinations of builds that could come off the line, and then we can make educated decisions on whether or not this is going to be acceptable or require an engineering change.
The way we have set this up is we're able to collaborate globally. So we can have representatives who are immersed in their virtual space, and we're immersed in our virtual space, and we can look at each other and talk to each other in real time on different continents inside the same model. So we have upgraded the software capability as well as the hardware capability, and so the vehicles that we see now are incredibly lifelike. We're showing that stereoscopic view in real time to a person or multiple people around the world, and then also in 4K. The level of detail that we can focus on now is amazing, and the customers see that in the end.
Pretty amazing. Recognize everything you saw on that was computer generated and was being shared by design teams thousands of miles apart, leveraging the power of the cloud. And I want to talk about a different type of collaboration that the cloud is enabling. This is the collaboration between man and machine. Now, since Ivan Sutherland, back in 1962 at MIT, invented the very first computer-aided design system, we've always thought of CAD as a tool for documenting design intent in the head of the architect, the designer, the engineer. It was the human's design that was documented in computer-aided design. But now, for the first time, we can, in a broad way, and in an economical way, change the relationship between us and the machine to one of true collaboration. There are many aspects to this. We could talk about artificial intelligence, machine learning. The example I'm going to share with you today is generative design. What is generative design? Instead of coming up to the computer and saying, here's my design, I'm going to draw it, you come to the computer and say, here's the problem I'm trying to solve. Here are the goals I want to achieve. Here are the constraints that I have to fit within. and let the computer come up with the design. Because again, with the power of the cloud, I can bring thousands and thousands of compute nodes to bear and generate hundreds or tens of thousands of alternatives with incredibly unpredictable results. Let me give you one example here. What you're seeing here is a concept plane from Airbus. About 5 years ago, Airbus said, we want to design the flying experience for the year 2050. Since I flew in here yesterday and it was a 12-hour flight, I wish they would redesign that experience a lot sooner. But what you see here is an amazing experience. Now, there's a lot of things that are going to have to happen technologically before that experience becomes real. But some of those things are already happening. Airbus is already starting to build that airplane of the future a piece at a time. And here's one example. What you see here is the bulkhead that the flight attendant's jump seat attaches to. Nothing special, we've all seen it. This is a great design. It's made with a honeycomb composite material. It's strong, it's lightweight. There's nothing wrong with it. But if you're going to build the flying experience for the year 2050, you've got to think further. You've got to push the envelope a whole lot harder. So what Airbus did is they took advantage of a technology we have called Dreamcatcher to specify the requirements for this bulkhead. What are the forces? What are the torques that it has to be able to sustain? How much weight can we remove? Because weight, of course, to an airline is money. Weight is fuel, is money. The machine was able to calculate thousands and thousands of alternatives. And what it came up with is a solution that is not only half the weight of the previous bulkhead, but still stronger. Now, this isn't just fantasy. They've already built this thing. It's already been through 9G flight testing. This year it'll be going through 14G flight testing. And who knows, maybe my next trip to AU Middle East next year, I'll be flying an Airbus that has one of these bulkheads attached. All right, we've talked a little bit about design and how the cloud is one of the disruptive technologies that's going to change the way we design the things that we build. Now let's talk about the building part, the make part. All right? Now, there are many, many things we could talk about. I'm going to touch on just a few. First of all, as in every industry right now, digitalization is having a tremendous impact on construction. We see that in BIM. We see that in mobile technologies and many other things. But we also, I think, overall have to understand that fundamentally what's happening in construction is every day it's beginning to look more and more like manufacturing. We're borrowing technologies, techniques, and methods from one domain into this one. And a great example is this company, ConnexTech. ConnexTech is a startup. They're based not too far from Autodesk headquarters, actually. And they had a vision to improve the way steel frame buildings were constructed. So they came up with a method for basically welding a dovetail joint to columns so that in the field, all you had to do to construct the building was simply slide the beams into place. There's no rivets, there's no welding. You just bolt everything together. Now that sounds pretty easy, but it's not. And among the many innovations they had to come up with, they had to come up with this crazy jig for doing horizontal welding of the brackets onto the columns. This new methodology allows them to do those welds 30% faster than if they were done vertically in the field, and with tolerances to thousandths of an inch. So what, you say? Well, the so what is, at the end of the day, they can frame up a 1,000 square meter building in a day. The one you see here took 8 men less than 7 hours to put together. But not only is it faster, cheaper, it can also be quite beautiful. As this example of one of ConnexTech's customers shows you, this is the Neuroscience Research Center at Stanford University. Fast, strong, beautiful. What else is happening in construction? Well, there's a company in the US called McCarthy, and they decided they were going to be the best construction company in North America. That's a pretty tall order. And you can't get to be the best construction company in North America if you don't tackle some of the toughest problems facing that industry today. And one of those, of course, is coordination. You look at a site like this and you can see that there are dozens and dozens of disciplines, hundreds if not thousands of subcontractors. It can be a mess. And we all know this is an industry that struggles with efficiency, with waste, and with cost. So what did they do? Well, of course, they started with BIM. BIM is really the foundation for all modern design these days. And they went to a project, in this case, the Odyssey Aquarium in Arizona. And this is a pretty challenging project. It's over 18,500 square meters, 3 levels, 9,500 cubic meters of concrete, and over 1 million kilograms of steel. And of course, they start with this, like all projects do, and they need to coordinate with the structural engineers, with the architects, with all the trades. So what they did is they invested in a product called Revit Collaboration. This is a tool that allowed them to leverage the cloud to bring together all of these various trades using the same models, the same data. They were able to get amazing results. First of all, communication was near constant. Information was available all the time. RFIs plummeted to less than 10%. Their turnaround time improved by 35%. And when they went to get their permit, their construction permit, their permit drawings were as fully coordinated as a full set of construction documents. But they didn't stop there. They took advantage of the cloud to move all that information onto the job site, because the cloud is also mobile. You put that information in the hands of the superintendents and the tradesmen on the job site. In this case, they estimate they saved nearly 17,000 man-hours in the project. All right, I'm going to change to a different area of making, and it's one that's very familiar to those of you here in Dubai, 3D printing. And when I talk about 3D printing, I don't mean plastic toy 3D printing. I'm talking about industrial 3D printing. And this is an area that's going to revolutionize many, many different industries. Anyone know what this is? Anyone have an idea? I see a hand. That is, in fact, a heat exchanger. This heat exchanger is pretty unique. First of all, it was manufactured as a single unit. There was no assembly here. It's made of aluminum. But as you can probably tell, it was not designed by any human designer. In fact, no sane designer would ever produce a thing that looks like this. It was generatively designed, much like that bulkhead I talked about a moment ago. Not only was it generatively designed, but inside of this heat exchanger is a randomization in the sizes and the shapes of the water passages that creates excess turbulence, which makes the exchanger more efficient. And the whole thing was 3D printed. And we're going to see example after example of this kind of technology in the coming years. Here's another example. 20 years ago, Under Armour came onto the scene to compete with the giants of athletic clothing like Adidas and Nike. And they've done extremely well. And this year, for their 20th anniversary, they wanted to design a special shoe. So they designed a shoe that they wanted to be the ultimate cross-trainer. It had to support an athlete through the most rigorous training regimen. They applied a lot of sophisticated analysis and ultimately turned to generative design again to design the midsole. And as you can see here, this midsole is incredibly complex, and the only way it could have been manufactured was through 3D printing. But of course, 3D printing isn't just about heat exchangers and shoes. It's also now about architectural scale objects. For several years now, a company in China has been 3D printing these houses. Low cost, they can do 10 a day. They cost about $10,000. Badly needed in a country where housing is in a tremendous shortage. But maybe it's not the prettiest looking house you ever saw, but that's why you've got this. And of course, you would recognize this as the temporary office for the Dubai Future Foundation, an entirely 3D printed office, in fact, the world's first entirely 3D printed, functional, code-compatible building. And this is just the beginning. All right, we've talked about design. We've talked a little bit about disruptions in make. Now I want to talk about use. Use is normally that part of the life cycle of a product where we, as designers, engineers, builders, lose touch with the customer. But today, through IoT and other technologies, we can actually stay with that product through its entire life cycle, learn from that product by feeding back information into our design and manufacturing processes, and in fact make the product smarter over time. The famous example a year ago of Tesla that had a problem in their electronic suspension control that caused ground strikes in certain phases of the driving envelope. They were able to upgrade all the vehicles, not with a recall, but with a software upgrade over the network overnight. Let me give you another example, and this is an example you probably don't see here very often. Snow on the airplane. But if you're like me, you run into this a lot. So what you see here are de-icing equipment, the equipment that has to get the snow and the ice off the wings prior to an aircraft taking off. And a few years ago in Seattle, there was a terrible blizzard. In fact, it was in 2008. 450 flights were canceled. Over 4,000 passengers were stuck in the terminal. Why? Because they ran out of de-icing fluid. You see, it's very important that when you de-ice an airplane, it's got to take off within a certain window of time, or you have to re-de-ice it. There was confusion. Planes were being de-iced and re-de-iced, and before you knew it, they ran out of de-icing fluid. So the company who makes this equipment, Premier De-icers, said, never again. I'm not going to be embarrassed this way. And so what they did is they created an incredible network of information. They instrumented all of their trucks. They instrumented their suppliers. They instrumented their de-icing fluid tanks. And they built themselves a dashboard that allowed them to know within 7 seconds every plane that had been de-iced, how long it was before it was de-iced, how much de-icing fluid was needed. They were able to tie this to their suppliers. They were able to tie this to their delivery trucks. So now they know exactly how much de-icing fluid is available at any of the airports they serve around the country. You can imagine this technology, of course, playing a major role in smart cities, a major initiative here in this region. Here's another example of use, a different kind of example. What you see here are the Bandito brothers. They're very famous Hollywood stuntmen. They also set all kinds of records, crazy things like this life-size Hot Wheels double loop. They were the first in the world to do that. They understand cars really well, and they worked with us on a project called Hackrod. And what they did is they took the chassis of one of those cars and they instrumented every bit of that chassis that they could with strain gauges, shear gauges, you name it, there was an instrument on it, accelerometers. And then they took that car, that chassis, and they went out in the desert and they drove it for hours. By the way, even the driver was instrumented. We were getting brain scans of how he was emotionally responding to different phases of the drive. Now, what you had at the end of this process was a database that told you everything about what an automobile chassis is going to undergo in the course of this kind of driving. So what did they do with that information? Well, you could probably guess, we fed it to a generative design algorithm. We said, here are the forces. This is what this chassis is going to undergo. Now, please design me the ideal chassis. And by the way, they did it in chromoly. They did it in titanium, they did it in steel. So they targeted several different implementation technologies, and the result is what you see there in front of you. All right, we've talked about design, make, use, and the disruptions that are coming to all of our industries. I have one last example here to share with you, and I love this one because it kind of ties it all together. What you see here is a project from a company called MX3D, working in conjunction with our Autodesk Research Lab to do something that's never been done before. Design and build a bridge entirely autonomously. Now what we've done is we've got a target for this bridge. It's a canal in Amsterdam. I'll show you a picture of it here in a moment. And the idea is we've told the generative design algorithm, here's the distance across the canal, here's the width of the bridge we want, here's the loading it has to survive, both dynamic and static. So those are the constraints. Go design it. Once the algorithm was done designing it, that information was loaded into these robots that you see here. And they're now in the process of 3D printing this bridge in steel in the air as they go, including 3D printing their own support structures as they cross over the canal. Now, in reality, it's actually being done in a warehouse in Amsterdam right now. The printing is actually underway today. For various environmental safety reasons, they didn't actually print it over the bridge, or over the canal. But as soon as we're done, in just a few months, that bridge will be located there in that canal. So think about that. All the things we've talked about today, generative design, machine intelligence, robotics, automation, 3D printing, industrial 3D printing, all coming together in a truly, truly unique example here. All right. So we've been talking about the future. Why is it so important to talk about the future of making things? Well, I believe the future holds tremendous promise for all of us. These disruptions are going to create opportunities for all of us, for our businesses, and to improve our lives. We're going to find new revenue streams. We're going to open new markets. We're going to create new levels of competitive differentiation. But there's also risk. There's risk in these disruptions, and perhaps the biggest risk is that we ignore them and somebody else takes advantage of those new revenue streams, those new markets, that differentiation. But I'm an optimist at heart, and I do believe William Gibson was right when he said, the future is already here, it's just not very evenly distributed. And our job at Autodesk, and your job, all of you out there today, is to make sure that that distribution comes unfairly and profitably to the Middle East. Thank you very much.
Thanks, Callan. Appreciate that. Thank you very much indeed. Cheers. Callan, thank you very much indeed for that great vision. Some visionary comments, some visionary input into proceedings. Hopefully that's got you thinking for the remainder of the day. Compelling, I'm sure you'll all agree, to know that these are trends, as we've just seen, not only to change the horizons of design potential, but that today they are being manifested through a variety of different industry classes, as was exemplified there. Technical presentations and the Future Tech Exhibition Hall as well. Talking of the exhibition hall, a lot going on down here in the main auditorium, loads going on outside as well. And I'd urge you all, when we do break at certain points during the day, to share your thoughts, to interact, but also to go and meet all the sponsors that have given their time up. They've prepared, as well as some great sort of presentations outside. So please do get involved in those, as well as the Autodesk Gallery, where you can learn from experimentation and live projects leveraging 3D printing, generative design, and even robotics throughout the day. The fourth industrial revolution, I know that's a phrase that you hear quite often these days. I think we are entering that. We're very much into that at the moment. A revolution driven by a combination of technologies, including sensors, computer algorithms, robotics, and material fabrication. It's a transformation that is sweeping, affecting just about every industry that makes things these days. And the fact that architecture, engineering, construction, and manufacturing are all now computable is opening the door to vastly improve efficiencies and remarkable innovations, as I said, has just been shown a little earlier this morning. These dramatically affect how we make things, how things are made these days, and the very nature of what is being made. So next up here, for another keynote this morning to get your thinking out there and to get you interacting on our social media platforms and sites. Hashtag AUME2016. If you're on your social media, please do send us your thoughts. We'll try and collate them throughout the door. We're going to be hearing now from a man who's recently completed a deep 2-year analysis of these core technologies for a forthcoming book on the future of making, to be published sometime next year. An individual who will describe to you how the interplay of digitization and materialization establish a capture, a compute, a create, and a compose workflow all in one seamless line. This is reshaping the way that we design, the way that we make, and the way that we use, as we heard earlier, cars, consumer products, infrastructure, apparel, and of course, the buildings that we work in and that we call home. We'll focus on how 3D printing and other forms of additive manufacturing will transform construction, a topic especially relevant to a lot of you working here in the Gulf. So without further ado, I'd ask you please to put your hands together, make him feel very welcome. He is Autodesk Fellow in the CTO's office. Let's hear it for Tom Wujec.
Thank you very much for that kind introduction. It's really great to see you here. It's fantastic to be here in Dubai, this magical city of the future. It's my first time here. I hope certainly not my last time here. And I'm just thrilled at the vibrant city. I've been through the Middle East before, but I've never experienced a city quite like this before. So amazing place. So I'm here to talk to you about some deep questions that Callan has posed. So you've heard about how emerging technologies are changing the way in which we design, make, and use things, but you might be asking yourself, which technologies, and how are they changing, and what can I do differently, and what should I do differently next Tuesday? So over the course of the next 40 minutes, I'd like to explore putting the spotlight on 3 key domains. The first is technology and the role of technology and how it's growing. Secondly is how technology is changing industries. And the third is creativity and the interrelationship of our ability to imagine something that's new and vibrant and to bring it into reality. Now, if there's one diagram that one kind of key idea that you'll remember during the course of the conversation today, I hope it's this image here that I'm building up. And that's this. Technology is growing at an exponential rate. It is compounding, building on top of itself. As a result of this and other factors, it's causing industries to rise and fall rather chaotically. And human creativity all along this is what? Is it increasing? Are we becoming more creative? Are we becoming less? Who thinks we're becoming more creative? Just raise your hands, okay? Who thinks we're becoming less creative because we're more distracted than ever because of this technology, because of cell phones, because of social media? Okay, a few. And who thinks it's about the same? So I would vote that generally we're probably no more creative than we were 500 years ago or 1,000 years ago. We still have the same number of neurons. However, technology is moving at this tremendous rate, and that's creating a gap and also an opportunity for us. So let's look at these in some depth. Now, you might be amazed to learn that according to the American Microprocessor Association, this year we will produce more individual constituent transistors than we will harvest individual grains of rice on the planet at a lower cost. That's amazing. Let that sink in for a moment. We're producing more transistors than harvesting grains of rice. Give you an idea of what that looks like. This is 1 million grains of rice that we put together for a conference not long ago. Thank goodness for interns, really, you know. So it's about a foot by a foot by a foot, and a typical smartphone that you have in your pocket contains about 1,500 boxes worth of these. That would fill this entire stage. We produce now 15 trillion transistors every second. How many boxes do you think that adds up to every second? Turns out it adds up to about this. If we put them all laid them on one level deep, it would occupy about this size, about 3.4 miles per this size. In over 60 seconds, it would fill all of, most of Dubai. That is incredible. They're so small, so minuscule. Of course, we can produce billions of them that would fit in the end of a period at the end of a sentence. Now, the reason this is happening is because technology is growing exponentially. Faster computers are building faster computers, and that is having a compounding effect. We know this, but our brains are still hardwired for linear thinking. We now need to get into a way of thinking that is exponential. One of the things about exponential thinking is that each step in a technology evolution is typically greater than the sum of the previous steps. And that leads to conclusions such as, well, according to Eric Schmidt, the head of Google, chairman of Google, we'll produce more data, more information this year, in 2016, than we will have produced in the year 2014, 13, 12, all the way back to the beginning of recorded history. That's amazing. And we're just at the start. And it's continuing to grow. Now, this has huge implications, and I'd like to give you one implication, and one is that things move slowly until they don't. This is a picture of a room in which the Pope was inaugurated. I think the term is ascension, in the year 25. I want you to look at if you can find any cell phones or smartphones in this photograph. Anyone? So one in the bottom, right? Okay, and we're going to fast forward to the most recent Pope. Same room. See if you can find any smartphones. Anybody? Right? Things move slowly and then suddenly. And let's advance to the year 2016 to a typical concert. And cell phones now, this technology is ubiquitous. 10, 15 years ago, no one saw it, and now it's just pervasive. It's visible around the world. That's true of every exponentially growing technology. And so the ones that that Callan has shared and that I'll be sharing now are on this same exponential growth curve. What does this mean if you don't take advantage of it? Well, and where are these technologies going? From the point of view of the future of making things, there's three classes of technologies that we really need to pay attention to. They are sensors, computers, and fabricators. And together, the synthesis of these working in concert enable us to design, make, and use in a fresh way. So let's look at each of these. Sensors really began as these large objects, thumbnail, or objects that were implanted. Now, today's sensors are the size, well, look at that, it fits between the gap in a fingerprint. That's a camera. That's a 2-megapixel camera. Isn't it amazing? And what these sensors allow us to do, among other things, is to create these remarkable three-dimensional imagery. They do much more than this, but this is a project that we worked on this year with the Smithsonian Institution, taking a LiDAR device, many of you are familiar with this, and then scanning the inside of the Lunar Command Module. What's amazing about this is with every form of resolution, as you get deeper and deeper, you get more and more detailed information, changes the phase. And look at this, you can actually see a scrawl, some writing from Michael Collins, who said, the best ship to come down the line. Isn't that amazing? So no one actually had seen that in 40 years, I think 50 years. This is an amazing statistic. A typical smartphone today has more computational power than all of NASA had in the year 1969. All of the plans, all of the buildings, all the logistics to send rockets to the moon and back is greater, or is less than what is contained in a typical smartphone. But that's not the real story. As Callan said, the real story is the fact that these devices are connected to the clouds that enable us to have virtually unlimited resources for computation. It enables us to take a generic laptop and to simulate, fly through an entire city complex in ways that required supercomputers just a half-decade before. And what this allows us to do is to simulate, analyze, and to generate new designs, and to be able to see the hidden world and the hidden connections. So computation allows us to abstract complexity in ways that we've never been able to do before. Fabricators, of course, are the devices that take digital information and materialize them, turn them back into the physical world. And there's really two classes of them. There's machines that subtract information, they cut and they mill, and they weld, and they are, of course, becoming more democratized. And then what we're paying close attention to, of course, are the devices that add material, additive 3D manufacturing. And of course, there's many classes and ranges of these. These are transformative, as you'll see. So the combination of sensors, computers, and fabricators are creating a new workflow that we like to call capture, compute, and create. And the combination of them changes not only how we design and make things, but also how we use them together. So this is a new workflow, which, as you've heard before, is called capture, compute, create. Okay, so that's the basics. Right? So how is this changing? How is this transforming industries? Well, you know, it's really interesting that once an industry becomes computable, everything changes. It kind of goes from a solid to a liquid to a gaseous state. And it's affecting virtually every industry, whether it's AEC. Think of one, from pharmaceutical to music to how we get taxis, telecommunication, education. It's all being transformed, creating this fluid state. It actually goes through several stages. I'll just highlight some of them. Once an industry is digitized, that is, information is captured, then it is disrupted because you can improve the efficiencies, do much more, and then eventually is democratized. There's other stages as well, but these are some of the key ones that we need to pay attention to. You're familiar with this. We all know this, right? Think of VCRs and how we entertain ourselves. No one today would invest in a company that would innovate by rewinding the VCR faster than anybody else, right? Because this technology has been overtaken and superseded by a range of other technologies, which of course are becoming increasingly democratized. Typically, in every minute, 31 hours of content are being uploaded to YouTube every minute. That's astounding. Who watches that? It's like cat videos and so on. Now, they're creating new types of business disruptions, and one of the most famous, of course, is the Kodak. So Kodak, which, by the way, was the leader in digital photography. They had actually more patents, 60% of patents of digital photography, compared to everyone else. Market cap, $28 billion, almost 150,000 people, but they didn't want to disrupt their core business, so they didn't really invest in it. In the year 2012, guess what happened? It was a new Kodak moment, right? The company is bankrupt, there's 17,000 employees, but at the very same year, a row of maybe right over there with 13 people created a company called Instagram and had a market cap of $1 billion, 13 employees. That's a pretty hefty return for 8 months worth of investment, isn't it? And that's just the beginning. Of course, it's just growing higher and higher. And today, as a result of this exponentially growing technology, no one knows for sure, but it's estimated that between 2 to 3 trillion photographs, not billion, trillion photographs are uploaded to social media every year. That is astonishing, right? Folks from Kodak said, who would ever want to watch look at a slideshow on a television? It makes no sense. We're not going to invest in it. So again, once an industry has become computable, everything changes in ways that are surprising, liquid, fluid, remarkable, innovative, and absolutely futuristic. Again, some examples that you know of. Netflix consumes almost 40% of the world's internet traffic. Airbnb has not a single piece of property that they own for lease, but they rent out 120 million hotel room nights every year. And Uber, now it's actually, this slide's 2 weeks out of date, it's now $65 billion of valuation. So the point now, of course, is this. Manufacturing and AEC is now becoming computable. And what does that mean? Well, it means a lot. Let's take a look at a few of some of the industries that are becoming computable. And I'd like to give you early glimpses of this and show how, you know, first there's that 1 or 2 cell phones, and then it becomes ubiquitous. So to plant some seeds in your mind of how this is going to transform the world. So the typical way of making a shoe today, mostly, is a designer begins with a last. This is a last. It's an approximation of your foot. It's more or less the size of your foot, and the designer begins to doodle and draw on top of it, making a sketch and another sketch, soon a 3D model. And over the course of several months, up to Now it's about 14 months, produces a physical model that eventually comes to your hands. So about 200 pairs of hands touch a typical running shoe, and if it's right, then your foot is, your foot will thank you, right? It's an approximation of your foot. How would a capture, compute, create way of workflow transform this? Well, you'd begin by capturing your foot with cell phone photographs or through other devices, as you'll see, and it produces a perfectly accurate model of your foot. And in other modes, you can change the dynamics of it. Then you upload that to an application that helps you decide what job you want the shoe to do for you. Okay, so if you're a basketball player, for example, it turns out there's 3 different ways of playing basketball, according to Nike. So there are dancers, and I can't dance like the folks at the front, they're amazing. And then there are jumpers, and then there are bulldozers. So those are the 3 different kinds of shoes, and so you can select what kind of performance you want and how the shoe should be reinforced, and then that information is sent to a combination of an additive and subtractive printer, which then produces this shoe. So it takes about a day now to produce one of these. I held my first 3D printed shoe, I guess about 12 years ago, and it was amazing. It was great. You held it, and it just crumbled in your fingers. It just fell apart. And then 7 years ago, you could put one on, and it felt great, and then you took a step, and it just fell apart. 5 years ago, you could walk around the room. 3 years ago, you could run a race. 2 years ago, you could run a marathon, and today, I'll show you what you can do with it today. Here's the state of the art of foot scanners. You'll find these in a variety of different retail places that will produce not only a model of the foot, but also the profile of how you walk, so how you get the best efficiency. This was done. This is the foot of an Olympic athlete whose name is Allyson Felix, and these are slow motion photographs of the problem to be solved. You might be surprised that at these hundredths of seconds, these little problems make the difference between no medal and a gold medal. She's an Olympic runner that runs the 200 and the 400, which has got a curve in it. So fundamentally, here's the problem. We run straight, and so as the track curves, we need to compensate, and our bodies don't naturally do this. So what they did is through computation, a variety of algorithms, they designed 2 separate shoes that perform different functions. One shoe acts as an accelerator, the other acts as a steering wheel. Isn't that interesting, right? So custom shoes to do a very specific job. And because her feet are uniquely narrow, using this advanced material science to quite literally create a new type of material that wraps around her foot. And it's a kind of fiber that is now commercially available from Nike. The technology is called Flyknit, and it actually represents a 4th C in the capture, compute, create called compose, which we won't go into much detail today. That represents the kind of technology that's necessary for the upper to give that perfect sock-like fit, and the bottom is actually computationally generated or generatively designed, and which you've heard about here. And here's this beautiful sort of inspired by the wings of a dragonfly soles of the shoe, and the net outcome was here. This is the first time that a 3D printed shoe has ever been used in professional competition, and they helped assist Allyson Felix to get 2 gold medals and 1 silver. Amazing technologies. That's not the real story, though. this is the real story. It's changing the business model because you no longer have to buy the shoe, you buy the intellectual property of the shoe that's right for you, right? The shoe becomes a commodity. You buy it for the one that is just perfectly right for you because we all have asymmetries, we all have specific differences in our feet. And you lease the material flow, so the business model is designed to be what's called cradle to cradle. And because sensors can be printed directly within the soles of the shoe and elsewhere, there's a subscription fitness service, so there's an ongoing relationship with the customer as a result of this. That's the change. It's not just designing and making, but it's also the actual application that this enables us. And also, gives us the promise of, this is crazy, hey mom, this crazy emergence of technology. Furniture, another example of these emerging technologies. So here I'd like to go a little bit more deeply into generative design and show you some of the amazing applications that it can be used for. And it's pretty surprising. So say you wanted to design a stool. You might begin with this particular shape, and a computer will allow you to then evaluate some properties that would be important to you. The strength, the weight, the tensile capabilities. And it would produce a simulation of the chair, which can then be analyzed for the performances that you want. But this time now you go through a loop and you ask the computer to generate a variation and another generation to produce 2, 4, 10, 1,000, 10,000, 100,000 examples and then plot out their performance capabilities in a large cloud. You then play God and select the performances that you would like to have, and then you get the right kind of trade-off that would be appropriate. And once you have the design that is just right, voila, a 3D print, and you have the shoe, the stool. Again, the examples are phenomenal. From 10 kilograms down to 3 kilograms makes this enormous difference. Not a very attractive chair, but what if we advance it further with something that helps optimize aesthetics and helps optimize comfort? So this is our most recent experiment done by an intern and also by one of our technologists that allows us to take the properties of the kinds of chairs that we would like to have, Swedish furniture, for example, and then embody the design language directly into the chair itself. And the results are really quite stunning. They're really quite gorgeous. So it does not look like a computer has generated this chair. And by the way, it's done by a 24-year-old and a 27-year-old with almost no computer experience. It's establishing the goals and the constraints and then allowing the computer to do the deep work and the calculation to produce the results that you want. It's not replacing the human in any way. It's changing the nature of the designer's role, moving from the shape maker to the person who's creating the goals and the constraints, and then allowing the computer to do the heavy lifting. So it's important to know that it's at this speeding rate. I mean, it's amazing. Look at these graphs. It took 3 generations for the telephone to be adopted by North American people. Radio, 1 generation, refrigerator faster, cell phone faster, tablet, smartphones, and AI. I've been working, as you've heard, on this book called The Future of Making. We're just going to press print in about 2 weeks' time. And I tell you, it's been amazing to go to travel the world and to see the kinds of innovations, and I'm just shocked and worried that the examples that we're going to be illustrating will be quickly out of date, but we think we're on track. What's the fastest growing technology in the history of humanity so far? It's this one. Artificial intelligence. Faster computers are building faster computers, and it is tremendously revolutionizing every industry that we're touching. This is the thing to watch. Augmented artificial intelligence is fantastic. Let's look 6 years ago to see the state of it. Let's turn up the volume, please.
Chicks dig me for 200, please, Jimmy.
You may remember this as
Kenyon's excavation of this city
Watson
mentioned in
competing
Joshua
and winning in
showed the
Jeopardy.
walls had been repaired 17 times. Watson.
What is Jericho?
Correct.
400, same category.
This mystery author and her archaeologist hubby dug in hopes of finding the lost Syrian city of Urkesh. Watson?
Who is Agatha Christie?
Correct. Watson?
Who is Mary leaking?
You're right. Watson?
What is Crete?
Yes.
Let's finish Chicks Dig Me.
And Mel?
Did you notice the scores? And so Watson at that time was about 13 mainframe computers about the size of a refrigerator off the internet. They had the complete information of Wikipedia, a number of other websites, a language parsing unit, and they beat the world's 2 best Jeopardy players. That was 6 years ago, 6 years and about 2 months ago. And now Watson has evolved. It is now, has had children, probably grandchildren, fits now inside of a laptop. Watson has read the American Medical Association journals, all of them. It's read the British Journals of Medicine. It's read every journal of medicine, and now has a better capability of diagnosing disease than 12 board-certified physicians. So what does that mean? Will you go to a hospital that has Watson or doesn't have Watson? And soon we'll be seeing that. Will you go to a technician that will diagnose your car that has Watson enabled or doesn't have? So these seem like unusual questions, but will be common very soon. So let's look at art, something that is most precious, something that is most creative, something that we think is mostly attuned to what makes us human. Can a computer help us reframe and rethink of art? Well, for example, if we wanted to create a new Rembrandt, one that has never been seen before, how would you do it? Well, the way you would do it is by looking at every Rembrandt that's ever been produced and studying it in exquisite detail and understanding the lighting, the eyes, the shapes, where it looks. And in doing so, develop a language of Rembrandtness, the quality of it. And then giving the computer new goals to produce a never-before portrait of a man, and we know how it would look, and we would know what direction that person would look, and that person would be likely wearing a hat, what the lighting would look like, and we also would be able to study the brush strokes and to ensure that as it's built up, the brush strokes actually mimic a true Rembrandt. Now we're kind of crossing into that kind of ook factor, isn't it? Where it's really touching what we think is most uniquely human, and this is the painting here. And experts today would say this is a lost Rembrandt, but it's generated by computer. We're at the starting point. So we're beginning to see this in apps, one called Prisma, for example, and on your iPhone you may want to download this, where we are able to transfer the style of computation from one to another. Our machine learning groups are now literally doing this kind of work where you can take a particular kind of an auditorium, for example, and tell the computer, make it more peaceful. Make it more peaceful. And the computer would be able to provide suggestions and alternatives to be able to switch the design to make it more look like that. So it's important to know also that technology goes through these various stages. We go through this phase of impossible. There's no freaking way we could do that. And then it becomes impractical, and then it's possible, and eventually it's expected, and then finally it is required. Technologies are now moving faster and faster through this loop than ever before. It took many hundreds of years for the airplane to move from its initial drawings to its current state, and now today's artificial intelligence are literally moving through this in months and soon days, possibly even hours. This is the growth of exponential technology. So what does this mean for buildings? Let me show you some early examples, and Callan has illustrated them. Here's some work that we're doing in our offices here in the university in Toronto. It's actually on the corner of University and College. We've secured this new building here. And of course, we want to have each of our 300 employees in Toronto to have the best experience possible. How do you do that? Everyone wants a low distraction place where they're working closely with their colleagues, viewed outside, and so on and so on. But how do you optimize for those 300 conflicting and complementary goals? Well, you put it into a generative design algorithm, and it kind of looks like this. You begin with the constraints of the 3 floors for the building, and then understand what are the various fixed, unmovable things, meeting rooms and social spaces, and then you introduce the 6 goals, and you start generating a variety of patterns that satisfy the goals. And you do it once, and then a second time, and a third time, and then you go through a series of evaluations, and over the course of a couple of afternoons, you produce 10, 20, 10,000 different views of this. It allows us to deal with complexity in a way that is previously unimagined. It's a way and allows us to take what is previously impossibly inaccessible and turn it into diagrams that we can clearly understand and navigate through and make sense of. These are those were the top 10 results, and here's what we finally selected here. So it's a tool that allows us to go deeply and to have insight in ways that we've never been able to do before. And here are some of the renderings, and we'll be moving in March. If I'm back next year, I'll let you know how it's worked out. But isn't that amazing? So this tool that we would think is providing for forms can be applied to other domains. That's part of the beauty of artificial intelligence. We've talked about this. This is a vision for Dubai and the UAE. What actually, though, is 3D printing at this scale? What does it mean? Is it additive manufacturing? Does it require concrete? Does it need to be built on site? These are questions that I know you're thinking about and exploring, and here are some thoughts on how this is being done. Is it 3D printing? It's an interesting facade for the SF MoMA, San Francisco Museum of Modern Art, where this beautiful, unique structure has been computationally generated and then milled, and then that milling is then cladded with a polycarbon, and you can see the scale of it here, and they beautifully fit together to create this just extraordinary facade, transforming what was an otherwise dull, crowded building into one that is now iconic. What about robotic assembly? How is Create changing that? Probably the leading organization for this is based in Zurich. It's ETH Zurich, NCCR. And this building here is an example of it. The roof of this building is built by robots to house robots that build buildings. Get it? it's kind of meta. But the interesting thing is that it's just a beautiful, gorgeous structure that you can see. Initially, 115 carpenters were going to be needed to be able to construct this building, but then they reanalyzed it with robotics and discovered they could do it with 11 carpenters. What does that mean for jobs? What does that mean for skills? What does that mean for the evolution of labor? And these are what some of these actually look like. Every nail is calculated and placed so they know the exact weight of this. If you double the number of nails, the entire structure would collapse because of the extra weight. It's a beautiful structure that houses these incredible robots that themselves are increasingly autonomous to do bricklaying. This is a form of additive manufacturing as well. So still in its early stages, this is what some of the tests look like from the outside. This is what it actually looks like in the field in Turin. If you look at the edges of these buildings, what do you see? It sort of looks like grapes, doesn't it? This is in a vineyard, or vineyard, pardon me. And so the precision of the placement of these bricks is largely beyond the capability of human hands, but here is done with remarkable precision. Additive manufacturing. We've seen this slide before. I'm not sure if I want to live in one of these buildings here, but the promise or the vision is perhaps we'll create a machine that has some large gantry structure like this that will physically fabricate the building. The interesting thing here is that complexity comes for free. The computer doesn't really care if you're printing a square gulag block or this eco-sustainable shape that makes the building cooler in the summer and warmer in the winter because of the air patterns. So again, this is the promise, and there are a number of leading 4 or 5 research institutions across the world that are striving to be able to do this. In a practical sense, some of the things that I think are going to be really driving this particular market is the use of reinforcements inside of concrete. These are actually built by robots that can create any desired shape at any particular scale. And so this, of course, is sped up. And this becomes the reinforcement, the rebar for concrete. And it allows us for something that's called infinite expressibility. So not only are we improving the performance of the building lowering costs, but we're also improving aesthetics. One other thing that's really important is that you scoop out the concrete in the middle and you reduce the amount of concrete from 30 to 60%, reducing global greenhouse gas and also reducing the weight of the structure. Oh, by the way, it's stronger because the reinforcement is actually where it should be in the side of the walls rather than the middle of the walls, which typical rebar uses. And finally, use. When we put sensors inside of buildings, they literally become alive, and we're able to monitor them and sense them and make sense of them and operate them through their entire life cycle. This is the most instrumented building, we think, in North America, and it's our current office in Autodesk in Toronto. And essentially, the sensors that are inside of these buildings have allowed us to reduce heating and cooling costs by 30 to 40%, which is substantial. Think of our winters. So again, that full loop of design, make, use is the promise of these emerging technologies. So exponential technologies are not only here to stay, they are rushing towards us at a much rapid pace. To really give you a feeling of what they feel like, I'd like to give you a sense of what it's like being in a self-driving car. Has anyone ever been in an autonomous vehicle before? Just raise your hands. Okay, great. So here's one. I have to apologize for one of my colleagues' language, so he got a little excited, but this is what it feels like.
The Hans team will never believe this.
Oh my goodness. Go is the right word. Holy shit. Holy shit. There's no fucking hands on that wheel. Oh my god. What?
It's driving itself.
Ah! Ah!
Anyway, that's what it feels like. For those of us who are not prepared in the world of exponentially growing technologies, when we first encounter it, this is what the experience actually feels like. And of course, the second time, you kind of go, this is cool. And the third time, you're taking selfies. And it becomes normal, just like every technology eventually becomes normal. So technologies grow at this exponential rate, causing industries to rise and fall, and creativity. Well, there's so much to talk about in creativity. I'm just going to spend just a couple of moments talking about it because that's really what today is about. But fostering innovation is why we're here. And fostering innovation is really about doing three things. First, it's identifying the problems that really matter. Secondly, systematically exploring solutions. And third is delivering elegant solutions. And great companies do this. They figure out what are the needs and the opportunities in the world. They explore the range of them. They select the right ones, and they do an amazing job of delivering them. So there's really, I think, 5 things that I'd love for you to take away with here. And that is, first, pay attention to these forces. Understand the forces of exponential change and develop methods and maps to be able to see which are the ones that are relevant to you. This is important because if you don't, as Callan said, your competitors will. Secondly, take advantage of the emerging technologies. Figure out how you can instrument your work, how best to capture, compute, create. How you get onto the digital highway and also off of it. Identify the problems that truly matter and solve them in collaborative ways. Take advantage of these digital twins because they offer improved efficiency and also improved tools for collaboration. And then finally, doesn't matter where you start. Start anywhere because I think it's truly all of our job to innovate. So the future of making is going through these phases. My question to you today is, where are you on this continuum? Where are you putting your focus? What is your thinking? Are you here in the world of the required? That's no longer good enough, I'm sorry to say. Average is no longer good enough. Are you in the world of expected? That's what your customers are expected. Are you in the world of the impractical? Maybe not, because, well, after all, it's impractical. But maybe you should spend some of your time, some of your precious thinking, creative time into the world of the possible, thinking about what could be and what will be arriving in the next days to come. And I think there is probably no better place here than right now here at Autodesk University. So with that, I hope you enjoyed this reframing about the future of making things, and I wish you tremendous success in your endeavors and enjoy the rest of your day. Thank you so much. Thank you so much.
Tom, thank you very much indeed to you for that chat, that keynote, which I'm hoping has got you guys inspired and ready to ask questions, because what we're going to do now is give you the opportunity to do exactly that. We're going to break for a well-deserved cup of tea, work on a few of those breakdancing moves, bit of networking out there in the pre-function area as well. But please, please, please do get involved in the conversation, whether that's old school talking to one another or equally on the social media as well. It's hashtag AUME2016. Please download the AU Middle East app from your Apple App Store or Google Play Store right now. Stay connected with social conversations. Your personalized agenda is on there, and you can also submit your Autodesk passport for a chance to win one of 2 high-end design workstations. I mentioned the word win and everyone stopped moving them, which was what usually happens at events like this. But what we're going to do now is head on outside, cup of tea. We'll be back in here round about 20 minutes, half an hour or so, looking to get things back underway at about 11:30. Enjoy. for the second session of proceedings. Remember, of course, plenty going on outside in the pre-function area, in the exhibition area. And if you want to find out a bit more about your passport, obviously it's part of your delegation pack, which is you were given when you came in. But do try and get these stamped if you can throughout proceedings this afternoon. And if you would like to go into the draw to win goodies later on, hashtag AUME2016. Right, we turn our attention now to BIM, Building Information Modeling. And we're going to be hearing a little bit about some of the insights gleaned from survey data drawn from consultants and contractors across the Gulf on the value of BIM to their operations and what factors are holding back others from adopting BIM in the region. We're going to be taken there by a civil engineer with several years of experience, an individual who is responsible for developing and delivering technology solutions to the architectural, the engineering, and the construction industries, not just here in the Middle East, but across India and Africa as well. Previous roles of Technical Solutions Manager and Technical Marketing Manager worldwide for BIM portfolio within Autodesk itself. He's been involved and, well, evangelizing about BIM since its early days. He shares the goal of enabling the full promise of building information modeling by simplifying its methods and developing new education mechanisms. This session is called The Business Value of BIM, a Gulf Perspective, and it is brought to you by Solutions Manager Consulting, Autodesk. Please welcome to the stage, Suhail Arfath.
Morning, everyone. I think we are back from the session. I think you would have got a fill of your coffee. I'll be having this session right after there's one more session before we go for the lunch. And I have got this subject today, which is really, really very intricate in terms of the details. I have tried my best to put it together in a story where each of us can relate to it and find the value in it. My name is Suhail Arfath. I work for Autodesk. I think Tom already introduced me a great deal. Thank you very much, Tom, for that. I have spent more than 12 years with Autodesk working various offices across the globe. And since last 4 years, I've been in the region, helping really the region to do implementation of the BIM, particularly the governmental agencies, owners, operators, and the large firms. Last year I spoke actually about the value of BIM and the BIM opportunity for the region, considering the large iconic projects we are building in the region. We looked on the stats and the data which was coming from the mature countries like United States, European countries like UK, Australia. This year, we're going to talk about our region, which basically means we have our own data from the region. We have our own people providing this feedback. What do they see in terms of value when they are implementing BIM on the projects? And where do they see BIM going forward for the next 2 to 5 years? So we'll drive out of this the trend, what's happening today, what your competition, your peers, your counterparts are planning to do tomorrow to deliver a huge inventory of the projects which is to be planned for this region, likes of Expo 2020, Metro Rail projects, FIFA 2022, and so on and so forth. And I don't have to tell you, we all know one thing is very constant in all of these projects. The deadlines are immovable. The deadlines are very tight. So today we are going to really look into the deep inside this BIM and what value it offers to you as AEC ecosystem, whether you are an AE firm, you are a consultant specific domain, or you are a contractor, subcontractor, building material supplier, or an owner operator of that facility or infrastructure. That's the whole goal. But before we go into that, it's important to understand for all of us, how did these findings came out? Who responded to it? Where did we get this data from? And how it was put together to come up with this list of findings, recommendations, and the future portfolio. To start with, let's look at the company who actually ran this research in the region. These are Dodge Analytics. Previously, a lot of reports you might have seen if you are around the BIM world or not living under the rock, then definitely you would have grabbed 1 or 2 reports from them to understand what's happening in the construction industry, what is so disruptive, named as BIM, and how it's changing the construction industry since last 10 years. So these were the reports delivered from the mature markets, specific domains, specific roles, such as the reports created for facility management, such as reports created for owner-operators, so on and so forth. Similarly, they did this research this year for Middle East, and this report is going to be released in Q1 of next year. What you are seeing today is basically a sneak peek, a summary, an excerpt from the report. There is going to be a report published out, which you can download probably free from their site and go into further details. Today, we will, as I said, we'll look into the excerpt, some of these details. Ideally, we all had to sign a non-disclosure agreement, but Dodge has been kind enough to share this data with us and allow the permission to use it in this event today. So let's look at which countries were surveyed, which countries users were questioned, asked, interviewed to gather all this insight. Right, if you're seeing here, the big portion is being played by Saudi and UAE. And then there's a section of 31% of the companies or users coming from other countries, which includes Bahrain, Egypt, Qatar, Lebanon, so on and so forth. And each percentage is there for you to look at. These are the respondent countries where these users are working on the projects or have an exposure on BIM. And these are the respondents. Now let's look at what were their sizes. What company types we were talking about, what were their employee sizes, how large were these firms. Predominantly, if you look at it, and unfortunately this thing is not bright enough. If you are able to see, we are talking about majority of these companies were AE firms, architectural and engineering firms, and then followed by dedicated architecture firms, contractors, subcontractors, planning, and some specific engineering. We also looked at this huge spectrum of the company sizes, And majority of the companies, if you see, are here, the company sizes in terms of the percentage who contributed to the survey. Now, that was the fact in terms of which companies were asked and which type of companies in terms of sizes. Were they small companies, medium companies, or they were fairly large companies like the global companies who are working out of the region? Now, if we go a little bit deeper, we'll see how we defined the BIM engagement to them as a question, and then users were asked, what is your level of engagement from the BIM's perspective so far? On the left-hand side, you can see the percentage of the users in terms of BIM users and non-BIM users. Now, you might question, what does this mean? The BIM users are the users who have been contributing or deriving or consuming the BIM data. And the non-BIM users basically are the users who probably are leveraging that insight to make decisions, but not necessarily are playing an active role in contributing in developing this BIM data. In each offices I go personally and meet these customers where the BIM is in the incubator or in the mid-maturity level, one of the things the BIM users or the BIM leads keep on talking to us is that we understand the benefit, we get it, but there are people who still work in the traditional environment, traditional workflows and processes. How do we help them understand this new way of working, new process? So that's where the survey did pay attention to those kind of users also, the users who are not day-to-day basis actively participating in BIM. That's where you see the 15% of them. Now, in terms of the level of engagement, we had high engagement, moderate engagement, and low engagement. Now, you can see again, if you pay attention, the most of the users who were participating in this research basically were highly engaged into the BIM projects, BIM environment, BIM tools, BIM processes, and pretty much everything related to BIM, which basically says their insight is going to be having a great deal of value for us to understand what's happening in the region, right? So let's go down and look a little bit more deeper. Now, what you're seeing here, we went further deep and started asking them what's their number of years experience in BIM. And we also started comparing it with the other geos, like of America, Australia, China. And I want you to see this very interesting thing here. This is the medium one, what we are talking about. 49% of these users basically are saying they are medium users, and 30% is basically the new one. And I'm not really talking about the evangelists who have been driving and leading these initiatives into these organizations. That's still 22%. Compared to what is the nearest closest to us where we see the long term is basically the China. We are better than Australia, we are better than America when the first survey was done. I want you to pay attention to the dates here. These are compared with their last reports. So do not assume that this is the current status. In 2012, when this report was generated for North America, this was their stat. And similarly, in 2014, Australia was generated. This is 2015 in China, and this is 2016 for Middle East, because we don't have a historic data for the region. But we wanted to compare when this study was done into these countries, what was their situation at that very point of time, to give us the context how we are placed with the rest of the world. Now, that was about the background of the survey, the background of the research, what was considered, who was considered, how they were asked, and how they contributed to it. Now, here comes the interesting part, which basically says, what were the findings? So we did spend several months with the support of few companies, and McGraw-Hill or Dodge basically went ahead and got all this rich data from these users. Now we have to start making sense out of it. We had to really start looking at the data deep inside and start making sense. What does it mean to businesses? To start with, let's look at this first stat. We said, let's look at the projects and these organizations and the percentage of their projects they are using BIM on today. At the top of the slide, you are seeing the first chart basically depicting what kind of projects percentages they are using today BIM on. And we are looking at regionally, Saudi Arabia is saying they are using, 43% of these companies are saying, or users are saying basically, they use BIM on less than 30% projects. But 35% do says that we use them from 31 to 60%. Then the heavy users, which says more than 60%, 22%. That means every 2 projects, every 2 organizations out of 10 actually are using BIM on 6 projects. Now pay attention to this maturity here. What does this really mean? That companies are either leveraging it today for design, they are leveraging it for the coordination, communication, stakeholder approvals. It can be various levels of maturity. It doesn't necessarily mean throughout the life cycle. Then, based on this, the users were also asked, how do they see the next 2 years? How are the next 2 years looking like? I was really impressed to see this here. In this area, if you look at 41, look at this growth on more than 60% projects. So from 22 to 41%, almost double. Users are forecasting that double number of projects will be basically using BIM in the region. And this is the same status if you look at UAE and all other countries, running really, really high. And then when we compare it with overall region, we see there's a strong forecast, a forecasted growth in terms of number of users, number of projects, and translating into a huge benefits. We'll talk about the benefits a little bit later after we see the findings. Now, that's a good question, but how do we compare ourselves with others? How is the region doing with others? Earlier slide, we looked into Saudi Arabia, UAE, and other countries. How do we do it against China? How do we do it against Australia? How are we faring against North America? In terms of current status, when I say current, again, this is when the reports were generated, and how is the forecast looking like when the users responded to those research questionnaires. Again, I do not hesitate to say that we are really, really doing well compared to other regions. This is first time we have gone into this kind of research in the region. This is the first time we have this kind of data available to all of you to give you an understanding what your peers are doing. And believe me on this, as we start going into the benefits and what your counterparts are doing, you will be amazed where the focus of all of your organizations is. Let's look at some of the further findings. The users, 71% says, if the BIM is implemented on a project, it increases or improves the collaboration. The efficiency of the collaboration changes and improves across the ecosystem, not limited to just design firms, but design firms and the contractors and the PMCs, and not to forget the owners, operators, and authorities. Another stat, it reduces the errors in the construction, one of the biggest challenges in the execution of a project life cycle. Users have identified that this is one of the biggest things for them, around 68%. The design firms identified that they are able to reduce their rework by 63%. That means every time there was a rework of 10 days happening in your organization, if you are a design firm, you are getting 6 days back to do something more, to do something different, to improve your quality, to improve your bottom line, or use those 6 days to win more business. That's money. That's what we are talking about. And for our estimation guys, for our sales guys, for the guys, the business development guys who really care about money, we are talking about better cost control. Half of the respondents basically saying that it gives us better cost control and predictability on the project. If you ask anyone, a project manager in the design firm, anything unknown to him in project is flagged as risk, irrespective of it's a better drawing tool, is it a better material they found out, but for them it's a risk because it's unknown, it's unpredictable. They have no experience, they have no exposure, they have no background or history to that. Similarly, if you ask a contractor, there's a new equipment which can save your 10% time on excavation. For a PM there, it's an unknown, unless and until they have an exposure to it. In this case, we are talking about having that predictability, we are talking about having that cost control, which helps the PMs or the project directors or the owners who control the money of the project to start looking at those savings, to start looking at allocating those resources for making more money. Either you save $1 or you make $1. So similarly, you can go on each one of them. I think traditionally they are same, but some of them which I discussed were my favorite ones. Let's look at the internal business benefits. I don't think it's unknown to any one of you. Most of the design firms and contractors today, when they are bidding for a project, the first thing they tell to the owner is, yes, I know BIM. Yes, we'll deliver in BIM. We'll give you the 3D visualization. We'll give you the BIM in the quantities, the coordinated model. Because if you are not saying so, your competition is. If you are not offering those services, your competition is offering and has been offering. Now, this is where you are looking at the new service offerings, the new business to the clients, less time documenting, more time designing. This is one of the favorite things for a designer, if he doesn't have to worry about that I have to explain it to my draftsman to document it. If I don't have to go back to this project to explain how this project is going to be documented. They just want to use their time designing. They just want to spend their time optimizing the design, producing a high-quality design, a futuristic design. They don't want to worry about documentation. They don't want to worry about the line weights and the text sizes and the outputs which go to the sites. So this is where the users really say, we are going to get more time designing, less time on documenting. Repeat business. Let me give you an example. Most of us in the AEC industry in past used to have these visualizations. First, we had man-made perspectives. Every big office used to have a high-end artist who could generate these high visual fidelity manual perspectives. This is what, Mr. Client, you are going to get as a project. Here is a big size sheet. Put it on your wall in your office or back home. But believe me, we all know this. I think 80–85% times when the project was built, it was not exactly what was shown in the perspective. Reason? It's not that you wanted to mislead the client. The reason was as the project life cycle passes from one stage to another, something happens. Something which is very constant in our industry. Something which is well known to AEC industry. Change happens. Change due to authorities, change because his wife didn't like it, change because he traveled to a new city and he got a new idea. And those kind of things, if you are able to give a virtual building, virtual infrastructure, exposure to your client and let him experience what you are planning to build for them and deliver the same thing on site 3 years down the line, 5 years down the line. That means credibility. That means trust. That means the client starts sharing the vision with you and he believes that you understand and get his vision. That helps a great deal in maintaining the repeat business. And I think most of the contractors would love this if we have fewer claims and litigations. Every time I speak to the contractors and the owners about these litigations, everyone believes one thing is really critical for them. Irrespective of who is paying for it, everyone hates the time they consume, the resources they consume. Let me ask you a question. How many of you agree on that statement? Okay. All right, so we have few contracting firms. So it's the time which kills people. It's not the money they can make or they lose. It's the time to solve those litigations. So BIM drives a great deal of transparency in there. Now, there is an argument down there which says 36% companies or users say it helps in the retention of the users. This is something where a designer, an architect, an engineer sees that he's learning something new, he's ready for the future, he has a path in his career, so that helps into that. So let me summarize in terms of the maturity. The established benefits based on the research today: increased efficiency across the whole ecosystem or project team. We're talking about reduced on-site coordination issues. We're talking about limited, minimized errors. And we are talking about reduced work and marketing into new businesses, winning more work. These are established based on the research today, which most of the users agree or provide a higher rating in this research. Then, if you look at maturing ones, the ones where the feedback was the minimum, less number of users contributed, less number of users said, this is happening today, but we believe in the next 2 years this is going to happen more. So look at these. Overall enhancements in the organizational image, because you are a firm XYZ, you are delivering everything virtually in BIM environment, you are going to give the owner transparency in terms of the design, quality of design, the cost estimates, and the construction execution of it. Less time in documenting, more time in designing, faster client approvals as we start seeing the visualizations play in the initial level role also. And most important for the contractors is basically the improved safety. If you are able to simulate the construction sequence, if you are able to simulate the constructability of the project stages, that definitely helps and improve the safety. Then there was this section also where users basically talked about emerging. In this region, users are already seeing the benefit in terms of the cost on the project. They are already seeing that in the next 2 years, there will be an impact on the cost reduction of the project. There will be increased profits. There will be fewer claims as BIM becomes a legal deliverable. There will be higher retention rates in the companies who are promoting these technology-based design workflows, who are changing, who are ready to go ahead and take the world head on and do the cool projects of this region by offering these innovations, these new ways of working, a new way of making things in the future. Now, if you look at another aspect of it, BIM needs investment. If you are implementing or planning to implement BIM, I think you all are aware of it, it needs investment. What kind of investment is there if it doesn't have a return? So every business guy will tell you, okay, you are asking for investment, where is my return? It doesn't matter how much is the investment asked. What matters is what is the return it's bringing in. Your boss, the people who run your companies, the people who manage these organizations really, really are always concerned about one thing, that's return. Budgeting and investment is the easy part. Defining a return on that is the critical part. Okay, so here what we're seeing here is basically the 79% of the users basically believe that if there is investment into the BIM, its ROI is positive. There are some users who believe there is 7% of these users basically believe there's a negative investment also. There's a negative return. And if I compare ourselves with the region like of Australia, which is the closest to us, and America, which is 62%, we are doing fairly well. Now, you might ask yourself, how is that possible? How did that happen? Why is that happening? Well, most of these mature countries started way too early. They learned as they fell. They learned from their mistakes. We had a benefit. We are learning from their mistakes. So we are saving 1 or 2 mistakes. The maturity of the processes, the maturity of the implementation plans, the maturity of how the people enablement has to be taken care of. One of the biggest things which companies used to forget when they were planning the implementation of the BIM across their organization was how to deal with the change management. If you are changing the process, if you are expecting the same people to do work differently, how do you manage that change? So those were the things where the region got benefited, and we are hitting their ground running. We will continue to learn from them, and I don't see that day very far, like these stats will be leading this wave globally. We will see this wave because the kind of projects, the infrastructure spending planned for the region for the next 5 years is unbelievably cool. We all, as an industry, have an opportunity to lead the global markets in terms of leveraging these technologies, these processes, BIM, to define the future of making. Let's look at the percentages in terms of what kind of percentages people are saying out of that 79%. When you split it down, 16% says less than 10%. What I want you to pay attention is the 51 to 100% people actually say 23%. This is the breakdown if you want to go into the nitty-gritty. How did we come up with the 79%? What was the breakup looking like? And how are we faring with the global markets? All right? Now, if you want to go a little deeper in the region, UAE is leading again. Unbelievable, 41%. Very, very high, 18%. So UAE happens to lead the region, and the region happens to lead the competition or the nearest global markets for us. I want you to look at this slide. This is a questionnaire or the research component where design firms, owners, and all these project awarding organizations were asked how much it means for you to have a contractor BIM enabled, BIM skilled, across Middle East, across China, across Australia, and North America. BIM expertise does not affect our decisions. In Middle East, it's 13% only. We require companies to be experienced in BIM. This is 45%, and 42% is the encouragement. What will this trend look like in next 3 years to 5 years? You need to ask yourself a question: what are you going to do to be on the front of this wave? How are you going to benefit and lead this wave? But in the meantime, let me show you how users responded to this question, what they are doing. Remember, there was a huge percentage of the users who were highly engaged in BIM, who were already busy delivering projects in BIM. How did they respond to all of this? Where are they investing? Where are they seeing the ROI coming from? Look at this. A similar trend, mostly in revamping their processes. Middle East has been really, really, really aggressive on it. One might have thought just this buying software. Call Autodesk, buy software. Okay? What was more impressive was this training component here. This is content. Because regional content, we need regional content. All right? Then there's hardware and software. What I also want to talk about this portion here. I can assure you this thing. Whether it was a small design firm I visited in the region, and actually this is applicable globally wherever I have met customers, or it was a fairly large AEC firm or a contractor. In early 2000, when we used to talk about BIM, people had some of the things were like this. I like to do BIM, but my respective consultant is not on the BIM. We like to do BIM as consultants, contractor doesn't want to do BIM. We both want to do BIM, but there are no manufacturing libraries or the content of the building materials and the equipments we are going to put in. We would love to do BIM across this ecosystem, but my owner is not asking for BIM. My client is not asking for BIM. And as we progressed, every organization of them are really busy investing on collaborations with these friends, colleagues, counterparts, consultants, contractors, design firms, specialized firms, including owners, to see how they can collaborate and leverage this huge wealth of information or data each of you as an organization is building under the name of BIM to benefit the whole project. So trend has moved. Now people lately has been last 3.5, 4 years, people are now asking, we are being asked for the BIM. My lead designer is asking me BIM. My general contractor is working on BIM, or the owner or the client has asked for BIM. All we are really looking forward for is, can you bring in some clarity on what do you mean by BIM, rather than just one-line statement. So things have started moving on. Can you still go ahead a little deeper than just saying BIM and define what the BIM means for you? What kind of deliverables are you talking about? How are you trying to benefit from BIM or the information or insight or data which is coming out of this? That's where these trends were not a surprise to us. People are looking at processes, people are talking about collaborations, people are spending on, and you say BIM training, it's not the software training alone. It basically means the enablement of your teams to work in the new processes using these latest technologies. Let's summarize now. Let's walk towards the final summary of what the things you want to take away from my session today. Next 3 slides, we'll talk about really high level of these benefits, and then we'll go into the conclusion side of it. First one, top benefits that increased the ROI. Improved productivity, reduced work, conflicts, ability, and new market, new business. Top benefits. These are which are going to really define ROI for you. Now, resources that would improve. What kind of resources we are talking about that will improve the value of BIM? If, as I mentioned earlier, more clearly defined BIM deliverables between the parties. Please, for heaven's sake, tell me more in detail what do you mean by BIM rather than just saying do BIM. Implement BIM. Start aligning it with your project goals, business goals, ROIs, the things which you can measure. If you cannot measure it, drop it. Do not do the BIM which cannot be measured. It has to translate into either making or saving the money. Find out that business reason why you are doing the BIM. All right? More owners are asking for it. Well, that's absolutely true. Give us the metrics to measure the benefits. We need more people in-house. We do not want to build a culture of the old world. There was a draftsman, there is an architect or engineer. Draftsman will convert the one-line diagrams of these engineers and designers and just, irrespective of that, follow on this. We have to upskill them. We have to involve them right in the beginning stages. They can contribute. They can let you focus back on your design. There's an opportunity. Start using as an engineer or an architect these tools, new process of design, sharing with your team, taking benefits from that. Same is the external forces. And this was interesting for me because I saw this in early 2000, I think 2004 and all. There was a huge trend of companies asking for outsourcing partners because modeling was given away. Because initial benefits or initial times, people were using BIM models for coordination. And it still seems to be one of the things which people think can help us. And that predominantly is towards the content of it when we talk about the modeling services. Now, factors that would most improve, these are, we talked about benefits, we talked about resources. Let's look at the factors. More BIM training and support, more contracts to support BIM deliverables. We are all aware, we still do not see the contracts where BIM deliverable is replacing the existing deliverables of DWG or PDF deliverables. More and more contracts need to start looking at it and start seeing BIM deliverables as a legal deliverable. They have also posted a question on the software vendors like Autodesk. They want to see more interoperability between the tools across so that they do not get stuck into the tools nitty-gritty, but they are focused on the project workflows. They want manufacturers to play a role, which basically says, if you are going to supply, actually, a few weeks ago, I was with one of the customers in the region. They are building one of the prestigious projects. And they said, we have built a BIM model, and contractor is about to give this BIM model back to us as built. The only challenge we are seeing is all the equipments placed in there are basically generic families. They are modeled by contractor to represent that. But we have a lot of work to do to add the manufacturing information there. And while in the discussion, I told them, who are your vendors who has supplied these equipments? Who are going to maintain it for the next 3 to 5 years? And when they showed me the top 10 companies list, 8 of them actually were offering BIM content on their websites. So I tell them, go back to their website, ask them exactly those equipment content, replace this content, you have got all the manufacturing information for facility management there. They were surprised, they didn't know. And this trend is going to go further and further. You will see more and more equipment manufacturers, all the building suppliers, basically continuing to develop the BIM content. In past, they used to give us basically 2D content. They used to give us PDFs. Then we started asking, no, we want DWGs with all these specifications and the catalog numbers and all. They started giving us, and now we see a trend basically which is allowing or making these manufacturers to provide the BIM content. More and more users want to start moving to mobile, social, cloud. They want to get away from those limitations. I don't have 64 gigabytes of RAM on my machine, so I cannot open a BIM model. My model size has to be restricted because I don't have a cool machine. They want to move to the cloud. They want to open these models onto their mobile devices. They're expecting these things to happen. In net, if I look at it finally, I want you to think of this and remember this. 79% of regions users are saying there's a high ROI on BIM. As per Dodge, this is the highest they have found so far in the last 10 years, whatever research reports they have published. I want you to start thinking about this way. Your competition, your peers, your clients are serious about BIM. We saw in the previous slides, they are planning, if not already in the midst of their plans, to implement BIM on more and more projects. They are streamlining, changing, revamping, updating their processes, their tools to start delivering more projects as forecasted on BIM. Just think about it. What does it mean for your organization? Are you part of this 79%? Or you are part of the rest 29? Just think about it. The second thing is, the forecast is strong. Owners, projects will continue to demand. Authorities like Dubai Municipality will continue to ask for it. There's a value, there's a money, there's a quality benefit for them. They would continue to ask for it, and they deserve to get this high quality information-driven BIM models as their deliverables. This is strong. Continue to look at it. Top of the investments are in the process change, content, and people enablement. Where are you investing? You start thinking about it. With this, ladies and gentlemen, I want to leave you with a video to think about what your peers are doing. This is the BIM Awards for the 2016 from projects this year, the companies and the projects which have got this award this year, or at least they were nominated. I'm going to play this video. It's going to be 1 minute long. You will have a good fun about it. I want to maybe let 5 minutes to answer 3 questions if anyone has. Or if someone has more questions or detailed, I'm outside throughout the day, grab me, ask me. But if you have any question you want to ask with the audience, go ahead, let me know. We'll wait for a minute. If not, then we'll play the video and walk out of the stage. Believe me, I am impressed, and thank you for your patience. It was not easy to sit for 50 minutes in a statistics class where I was just talking about numbers. So thank you very much for your patience. Do we have any question? Goes to, thank you very much.
Sahil, thank you very much indeed to you for your insights into BIM, and hopefully that's been insightful for one and all this afternoon. We're going to have one more session, then we break for lunch. We're going to turn our attention, we'll continue the conversation with regards to BIM. We're going to turn our attention now to transportation. This next session is called Driving Simulation for Transportation. It's going to allow you to understand the advantages of driving simulation for highway projects, the use of 3ds Max to optimize infrawork road models, setting up an open driving simulator project using a driving simulator to review highway projects and more. Now, the person to take us there is an individual with over 15 years experience in construction, during which he worked on challenging global projects. He believes that effective communication means all players understand and can contribute to the design at the right time. Immersive technology, if you like, provides the interface. It connects people with digital models in construction projects. He helped his company, AECOM Middle East, to develop immersive content for regional projects using a variety of technologies, which will be highlighted for us during this presentation. Virtualization, augmentation, virtual reality, just a few of those. Deployment of platforms include VR headsets, smart devices, touchscreens, web and projection with head tracking for holographic interaction. I'm going to allow him to tell you a lot more about this during the next session or so. If there are any questions that crop up during the session, please, please, please do direct them to the social media platforms using the hashtag throughout proceedings. But without further ado, ladies and gentlemen, join me in welcoming up onto stage for driving simulation for transportation projects. It is Charles Dunk. Please welcome Charles Dunk, Civil BIM Manager.
Hello everyone. Thanks to Autodesk for inviting me today to talk about driving simulation for transportation projects. We've got a journey today, if you excuse the pun. We've got about, I'm going to talk for about 50 minutes on driving simulation. We're going to go through the why. We'll talk about why we would need driving simulation, what's the purpose of even doing it. Second section, we'll look at the what is out there, what's the options for you with driving simulation. And then finally, we'll go on to the how. We'll dive down into the nitty-gritty, the Autodesk solution for driving simulation on transportation projects. I've got 15 years, as mentioned, 50 years experience in civil engineering across the world, in the UK, New Zealand. I've worked on the contractor side and the consultant side. I've been in the region about 8 years. So I think I've got some experience there that allows me to understand a bit of the risks involved at the pre-construction planning stages, the concept stages through to the construction stage and the operation side. And so driving simulation is a way of looking at this risk and managing it and making the projects move forward. How do we currently visualize projects? We use renderings. We use, increasingly, we've got software like InfraWorks. We'll use nice rendered videos, maybe, and reports, drawings. But not everybody can understand these, particularly when we're engaging stakeholders, when we're engaging utility companies and the general public. There is a natural way to interact with the digital content, and we're going to explore that today. So, what is natural interaction? Natural interaction is intuitively understanding your environment, your digital environment. And we're probably familiar with virtual reality. We've seen there's been a lot of publicity around virtual reality. But virtual reality is not necessarily the right solution in this context. It's partway there, but how do we explore transportation projects? Typically in a vehicle of some description. Or we will walk around, or we'll cycle around, or we'll move around our environment at ground level. A lot of these visualizations that we see out there, we use these software like Navisworks or InfraWorks, and we'll have almost like a helicopter view over the project. Virtual reality isn't for everybody. I don't know how many in the audience have tried it. I think there's a threshold, there's a tolerance for how comfortable. Some people will put the headset on and they can't deal with it at all. I find from use of virtual reality with clients and colleagues, there is about half of people, maybe a bit less, find it uncomfortable. I think that's going to improve as the technology, we're still on the first generation of headsets. But so, VR is good and it's improving and it's a good way of interacting, but we need to find another way or a more intuitive way of exploring our designs in transportation. After talking with software vendors this year, not only Autodesk, we're seeing convergence of the capabilities of our computing power with our collaborators in the project. And what I mean, that didn't come out well, is now the software being used by engineers, architects to design their projects is now capable of actually driving good-looking and realistic visualizations within that software itself. This is called real-time design. So we're not limited now to actually sending off our content to a visualizer, to a 3D designer. We can actually see what it's like actually at the coalface, the guys doing the work. Continuing with the why, we're still in the why stage. So getting approval is a big challenge at the early stage and in any region for large transportation infrastructure projects. We have many stakeholders, landowners, we have utility companies, we'll have statutory authorities, the general public that we have to engage and to get projects moving forward. And it's a major risk for the collaborators, particularly in pre-construction, to get these projects moving forward and get them going to the tender stage. So I wanted to demonstrate, pull back the curtain a little bit, what we're doing in AECOM with driving simulation. Now this looks a little bit funny on the screen because what you're seeing, if you can try and imagine, this is actually a completely 360-degree video. If you imagine a piece of paper around your head and then unwrapped, that's what you're seeing on the screen. This is actually the video that was put inside of in this case, a Gear VR headset to demonstrate to our client what it would be like to drive along their new road scheme. We developed this content because the client asked us, hey, we want to understand the project a bit more, we need to engage our engineers, our management. And we were proposing in this project something that's a little bit unusual. We were proposing a road scheme. You're probably familiar with driving around Dubai or in this region actually, where they use the American standard for geometric highway design. There's these cloverleaf junctions where now we were proposing not a cloverleaf junction. So this added risk to the approval process or added extra duration. So we developed this VR experience to demonstrate different parts of the project, and it ran for about 3 minutes, and we put the driver at different parts of the project to demonstrate how they would change lanes, how they would accelerate, what they would see from different parts of the project. So relatively simple, sort of low-level visualization, not the greatest quality of graphics if you're familiar with visualization, but it was reasonably successful. So at the other end of the scale of simulation, this is in the UK. This is a university, Leeds University. They've let us use a couple of £1 million simulator. This isn't a flight simulator, this is a car simulator. And in some ways it's more complicated than a flight simulator because it actually moves on rails to simulate your horizontal and sideways movement. We're using this simulator, we've been engaged by the UK Highways Agency to explore and understand the impact of traffic management on driver behavior. We're probably all like, well, it basically makes you angry. No, this is to understand how do they react to different types of traffic management, cones, barriers, signs, illuminated signs, how does it affect them during the day, nighttime, and it's part of the all lanes running that they want to, the UK Highways Agency want to look at how to get the most out of the existing highway infrastructure in the UK. So that really is the either end of the sort of the scale of simulation. So, talking about the hardware and there's a scale. We're now moving into the what stage, of what's available out there for the simulation. So the cool stuff, the big stuff, this is awesome, and this is General Motors, where they have a full-scale setup. Hydraulic actuators underneath the vehicle, the dashboard works, and some very high-quality visuals in there. And GM use it internally for their own engineers to understand if they change the interior of a car, how does that affect the driver. They use it for getting highway to get them the safety rating. And they use it for engaging the general public, marketing obviously, and other uses. And this is a top-end setup. So we're just talking about the physical setup for now. We'll go onto the content shortly. I don't want to say right at the other end, but at the other end, towards the other end, shall we say, of the physical setup. This is a commercial off-the-shelf COTS, commercial off-the-shelf type setup. You could go to Visaro's website, pick, I want this type of seat, I want these type of screens, and they'll put it in a box and send it over. This is still very sophisticated technology. At the back, towards the back of the seat, you can see the little pistons. They're actuators. They're actually electric actuators, which will move them around. We're still talking in the region of 250, 300,000 dirhams, so not pocket change, but provides a very realistic and immersive experience, which is what my group in ACOM's all about, immersive technology. Something that's interesting about this particular setup is that if you were lucky enough to be a racing driver and you have your own Porsche GT, you can unclip your steering wheel from your real car and pop it into the steering wheel here to give you that real sort of sense of simulation. And it really relies on very good laser scans of the racetracks. Now, I said virtual reality towards the beginning of the presentation is not the most natural way, but if you couple it in a transportation context with a cockpit, this is a fantastic way of actually combining virtual reality and transportation projects. One of the issues with VR at the moment is presence. And what I mean is being able to see yourself within the digital environment, because remember, your vision is completely obstructed by the VR headset. So when you look down, you either see nothing or you see this digital representation of somebody else. And this this can break the feeling of immersion. They're working on it, and I've seen types of scanners that will scan you as you've got the headset on, so you can actually see what you're wearing today and not just generic. What's good about this is that the software knows where you're going to be. It knows where your hands are going to be touching the steering wheel, you know your feet are going to be on the pedals, and if you change gear, your hand's going to be about here. So the software, without actually having to scan you, knows where you're going to be. So you can see, in the digital world, you can see your hands on the steering wheel. You don't move around much, as in physically, although virtually you do. I would just add a note of caution with regards to actuators. A lot of people want to go, oh, let's move the seat around. In a transportation project, that's not always necessary. With car racing and you're banking around these 20% corners, you want to experience that movement in the simulator. In transportation context, we won't be going 250 kilometers an hour. I hope we won't be. So these actuators, they can lead to, they are difficult to implement, and they don't necessarily provide a lot more immersion. The virtual reality, coupled with the headset, great way of implementing driving simulation within transportation projects. We don't have to worry about modeling, like physically building the interior of a car. We can simulate Toyota Corolla and Mercedes and all different types of vehicles. So earlier, we showed the Gear VR, and we had the video with the wraparound video. This is what I call, I haven't found anybody else, I call it driving simulation, because actually you're just sitting there with a headset on. There's no other interface. So that was what I would call driving simulation, inverted commas. You're in a car, but you can't control it. And if you noticed in the video, you were sat, or the user was sat in the driver's seat. And I think if I was to run that again, I would actually put the user in the passenger seat, because you can't actually control where the vehicle goes, the acceleration, and do anything with the indicators. So that was sort of driving simulation, but as a passenger. It's still a fantastic way of creating driving simulation. We can have very high quality visuals. We can spend a lot of time with the computer at the back end and do these very highly rendered experiences. But it's not interactive. You put the headset on, it runs for 3 minutes, take the headset off, and that's it. You can't explore further. You can look all the way around, great. You know, you can pause, you can hold it, you can look over your shoulder. But not interactive. So driving simulation, that level, adding that interactivity is very challenging. You must model the environment digitally. You must have interface with the hardware. You must know what hardware displays you're going to be using. When I rehearsed this with colleagues, they thought that was a photo, but it's not. That's a rendered image from Project Cars. Grand Theft Auto. Does anybody, you've probably heard of Grand Theft Auto 5 and these other games. Grand Theft Auto cost $250 million, cost Rockstar Studio $250 million to make. That was their investment on their side. They model, if you're not familiar with this game, it's for the consoles. It has a very large artificial city where you can drive around. It's fully interactive. You can go explore buildings. You see people walking around, and it's a very highly detailed, data-rich city. Project Cars, which you're seeing on the screen, focuses on the experience of racing around racetracks. So they don't model whole cities, and they don't necessarily have pedestrians walking around, but they focus very heavily on very high-quality physics, high-quality visualizations around racetracks. This sets the bar. This makes it very challenging for companies like us who are in the construction industry and trying to do driving simulation. We can't get that level. We don't have $250 million to invest. The client doesn't have that. Why would they? We only have Rockstar Studios can sell their game 10 million times. We can only sell our driving simulation once. So to try and get that level of realism is extremely difficult, and we need to make sure the simulation is focused on what's on the outcome that's required for the project at the different stages. It's very easy to get focused on the visuals, particularly the virtual reality. Everyone is like, oh my gosh, that looks amazing. But we've got 6 senses. I know there's the movie Six Senses, 5, 6. The one that the people are not aware of is called proprioception, which is where all your limbs are in space. But we need to engage all the senses, and one of them is also your motion, which is your inner ear, your vestibular system. But we need to think about the sound, making sure that the sound is the right. I mean, temptation when you get one of these simulators like we saw earlier, put it in your house or in the workplace, crank the volume up because you want to have that experience. But if you're driving a Yaris or a Ford Fiesta, it's not going to be loud. So you need to set the physical setup corresponding to what you're digitally representing. And talking of digitally representing, we need to represent physics. And this isn't the exciting part of simulation, but it's what goes on in the background so that the weight of the car is simulated, so that your acceleration and deceleration and your braking. Your steering, your turning circle is realistic, and that when you turn the steering wheel, you are actually turning the same amount in the software. You need to represent the physics of collision as well, the energy involved in your collisions. Something that's quite challenging and the computer game designers would understand much more is about artificial intelligence. And when I say artificial intelligence, I mean of the other digitally computer-controlled vehicles and pedestrians inside your model. They need to react naturally, particularly like in the earlier one where we were looking at acceleration and deceleration areas emerging. We need to have a realistic approach from the computer-controlled vehicles so that it's a genuine simulation and it's not just a game or something that's good looking. So the physics behind it, the artificial intelligence behind it is very important. But having said that, we can still use driving simulation without needing to go for the top end. We can achieve some very good results with using simple visualization and simple physics, particularly around some types of understanding distraction and understanding the spatial relationship on projects like master planning projects, for instance, where we're not looking at exactly driver behavior, we're trying to understand the flow around a new residential housing estate or a new master planning city. So there's still a scope for controlling. We can control the physics, make it simpler to drive. We don't have to worry about exactly the steering wheel. We can have low polygons. This is a great way of also being able to pare it down for mobile devices so that we can engage the general public with a mobile app. If we know that it's low polygon, low physics, it's, I'm going to say easy, but it's easier to implement into mobile devices. Still on the how, we're gonna go towards sorry, we're in the what are the options, and soon we'll be getting into the how we do this. This is a courtesy of Cruden, who make the top end, that sort of simulator that we saw at Leeds University, that sort of scale of simulation. They do the big simulators. A lot of these companies start off in, they do military simulations or flight simulation, and then they realize that there's a market for car simulation. If you were a client or somebody considering simulation, then at the top of the row there is the hardware setup. How much do you want to invest in the hardware? But then you don't want to spend $2 million on an amazing simulator and then not have great content. So the second half at the bottom there is about the content, making sure that the content is suitable, and why are you implementing driving simulation to begin with. There's an interesting look into people's psyche about driving simulation and using simulators generally, and I was quite surprised after talking with colleagues in the UK, but it also is one of those ones when it seemed obvious afterwards as well. You have to be careful with driving simulation in terms of training people. That if you put somebody inside a simulator and say, right, okay, we're going to learn how to do skids, you're going to learn how to manage a skid. there's statistics have shown that actually they are no better afterwards than they were before they used the simulator. In fact, it can lead to overconfidence. Putting people inside simulators can lead to them having bad driving habits because there's no consequence. Half of the people I stick in our simulator in ACOM, in our office, they go, great, well, I can do all the things that I can't do in the real world, and I drive over the grass and I drive through red traffic lights because there's no consequence. And this can reinforce, if you're seriously considering the use of driving simulation for training, this can actually reinforce bad habits. So we can use simulation for something, as I mentioned, like to say distracted driving, because we're testing the person's ability to cope with multitasking. And actually, they could be on a flight simulator or they could be doing knitting. What you're testing is their ability to, how well they drive around their environment before they're on their mobile phone or tweeting or whatever they do. And then you test them before and afterwards and see how well they do. So you can use driving simulation for things like testing distracted driving. Now, you say, but hold on, airlines use flight simulators all the time. Should I be worried? The reason why flight simulators work in the airline industry is because of the preparation and the consequence that's involved. Obviously, there's the moral consequence of the pilot and his responsibility to the people on his plane. But the consequence in terms of his career and his ability to progress and even actually to be a pilot. So flight simulation works, and I'm sure there's somebody who could talk about this for much longer than I, but it's simply put, it works because there's consequence and because the amount of preparation that they use the driving simulator, use the flight simulator for. They prepare many, many hours before they go into the flight simulator. So it's not a magic bullet, but it is a great way of supporting the culture of improving safety and training for driving. A little plug about ACOM, and then we're gonna dive into the nitty-gritty how to use Autodesk's solutions for driving simulation. I feel really confident with the support that I get at ACOM because we're a global leader in infrastructure and transportation projects. We have, last count, about 85,000 people in, I think, over 300 offices around the world. We know, or we think we know, transportation and infrastructure. We don't design cars or motorbikes or any type of road vehicle. So we can use simulation ourselves to bring those two together and understand how do different types of vehicles cope with our roads. Now we'll use traffic simulation software like Vism. We will use other software to simulate the flow of traffic, but what's it like for the end user actually moving around the project? That's where driving simulation comes in. We have in the US, it's funny, ACOM's one of those companies that you suddenly find out you've got a whole nother division. It's such a big company. We have a team in the US that works with the Department of Defense, and when you work with federal authorities in the US, you have to actually own the rights to your product that you use or you're selling to them. So we actually built from the ground up our own physics engines, our own simulation engines, the interfacing, the hardware interface to work with the simulators that the Department of Defense has. So we, combined with colleagues in the UK, the support I get from the transportation planners, the highway engineers, the guys in the US, I think that we're well placed with simulation both here and globally. So we're going to get into the into the how we do it now. And this is the Autodesk event. Now, when I approached this and I was talking with the events, I was looking at a piece of software called the Open Driving Simulator. That is mentioned in the blurb, but it's we're actually going to use another platform, Stingray. You've probably heard of. I'll be happy to field questions about the Open Driving Simulator. I'll briefly mention it, but we're going to dive down into the Autodesk workflow or pipeline for creating driving simulation. But if you're out there and you're deciding, right, okay, this driving simulation, I want to test the water, give it a go, I don't want to spend too much money. This is the different options for you out there. And the first one is what we're going to dive into later, which is game engines. The Autodesk Stingray is the game engine we're using, but if you're familiar with these types of platforms, we've got Unreal and Unity, and there are a few others out there. They're a great tool, but they have quite a long development time. They require a lot of man hours. They need a lot of skill, but you are working from the ground up, so you can build a very bespoke solution. You can control the physics, you can control the visuals, sounds. You can start to add in the hardware interfaces and really manage it yourself. The second option is the existing visualization packages. So I'm talking about software like Navisworks or similar, where we can, and if you're not familiar with Navisworks, it's a great tool. You can just basically pour any type of data into it, Civil 3D, InfraWorks. You can drop in all types of content, and you can explore your transportation project in there. Now, it's difficult to actually do driving simulation, if not impossible. There are ways of mapping steering wheels, pedals, joysticks to keyboard keystrokes. Not great. It's more this type of software is designed for this helicopter view or creating visualization renders, videos, sorry. But still, a way that you can do it. There's a third-person view typically in software like Navisworks, but you kind of have to press forward, and it's like you're bionic man and you're running 1,000,000 miles an hour. Third type of navigating around infrastructure projects is real-time software. So I'm talking about InfraWorks and other tools like that, where we can explore our environment, where the software vendor has provided an interface which is like a driving simulation. But again, you will have to just cope with whatever the vendor has put in there to support the hardware that you're using. The R&D simulation packages. These are software suite that is manages that big bubble multi-million-dollar simulation that you saw earlier from Leeds University. This is a type of software package that's very unique, and you'll only find it. They only sell 10 licenses a year because they're very unique. They are, in terms of the physics anyway, they're the top end. The top end of the scale. You could simulate the amount of fuel that's in your engine, the type of polymer that you've got inside of your suspension, amount of tire wear that you have, because this is a very, very high-end simulation. We explored it, but the cost is fairly exorbitant unless you're going to be using this for, let's say, car manufacturer. And the last one, which is a great way of dipping your toes, and I'd recommend this to anybody who's starting on the road, is to get an existing driving game. We tested Assetto Corsa, if you're familiar. There are others out there as well. I think Forza and I think Project Cars as well. They have the facility to be able to have custom tracks, custom roads. It's not as straightforward as just copy-paste, going into InfraWorks, right, I highlight this area, got to put it in there into the racing simulator. It does require a bit of work, possibly in Max or some other software like that. But you know, if you're using a gaming engine, you know that the physics is going to work. It comes preloaded with a whole bunch of cars. You know that they've already done all the hard work around the hardware interface. If you're going to use different types of steering wheels, it controls all your monitors or projection. So it's a very simple way of starting off on that road in simulation. Now, you can't just go to online and spend $20 and download a copy of Assetto Corsa and think, oh, that's only cost me $20. You actually have to use, their license prohibits that type of use, so you need to make sure that you look closely at the license. You'll be talking about a couple of $1,000s to be able to use it as part of your own projects. If you are making revenue off the back of that, then you have to be careful with the licensing. There's also branding issues as well. Obviously, when you switch it on, it'll be all Assetto Corsa this or Forza that. You can't control the. You want to have your own company or the project branding on there, and that's not possible. So we're going to focus on option 1, which is the game engine solution. So there are the steps to simulation. To be able to create your own simulation content is, first thing to do is obviously the environment, the modeling, what we're going to drive around. So InfraWorks, great tool of choice. I really enjoy using InfraWorks. InfraWorks is a really good tool for developing that model. If you're thinking about multiple iterations, you can use the proposals options in InfraWorks. You need to model existing conditions. Typically, transportation projects have some kind of existing conditions that they interface with. We're not building a road on Mars. We're actually building a road somewhere where there are going to be some other roads or highways or built environment that we need to model. So we can use tools like InfraWorks, which understands GIS, understands laser scan data, traditional survey data, a bit like Navisworks. It has a similar like data import option that you can just pour about pretty much any data and more into it. It's a great tool for developing your model that you're going to be, or your environment, sorry, for driving around. But it's still at the early stages, so that model is not necessarily going to be able to just drop it in. I wish that was so, and I think talking with Autodesk and that they're going to be supporting this in a similar way to Autodesk Live. If you've heard of Autodesk Live, that's a great way of turning Revit models into these virtual reality environment. It's almost one click and it's done, and you can stick on a headset. That's the intention, or it's one of the ideas in their pipeline. But currently, we have to clean up the model, and by that I mean for the technical people out there, we have to make sure the normals are facing in the right direction. We have to fix textures. I'll go on to a little bit about that later. The next stage is content gathering, and what I mean is the other assets. So we've designed, typically highway engineers, planners will think about, well, okay, the buildings and the roads, and but we need to have realistic vegetation. We need to have all the sort of content that you get if you're a computer game designer. So you need to have the other vehicles relevant to your area. You need to have, if you've got pedestrians, you need to get culturally sensitive pedestrians. Do you model those yourself? Do you buy them? Where do you get that content from? Because driving around a ghost town isn't really very realistic. So the next stage is to gather the content. After that, we've got, this is where we're moving into the gaming environment like Stingray. So we'll take our rationalized, our fixed assets that we've sorted out, and we'll start to build our own little sort of SimCity environment. We might use paths that come from Max, or we might start to populate and put in roads from using Stingray itself. we'll start to put in pedestrians, we'll start to maybe put in, if we're modeling Dubai, we'd start to put relevant buildings in. We could use low polygon, low texture like we see, sorry, on the next slide. Or we can use these highly rendered, highly detailed models of buildings within Dubai. Testing, so that's testing by the developers themselves, by Immersive Technology Group. We would test it just to make sure it actually runs stably. But then there needs to be a testing on the target hardware, and if it is going to be going, so we need to make sure it runs on the hardware correctly. If it's going to be on the mobile devices as well. And then finally deploy, and in fact, I probably should have put a feedback loop, because from deploy, we're looking for feedback, and not only feedback on the transportation project that we've modeled, obviously that's pretty much the primary reason why we've developed this model is for exploring the environment. But we as the Immersive Technology Group, we need to have feedback on how did it run, did the software run okay, was it stable, what was the experience like, could you drive through something that you're not meant to, and vice versa. So that in a nutshell is the Autodesk workflow as it stands for driving simulation, starting off with InfraWorks. So now I'm going to dive down in those 5 or 6 stages. We're going to look in a little bit more detail for each of those bubbles. So rationalizing the environment, if we were to use an InfraWorks model directly in Stingray, it wouldn't run, or it might run but very badly. So we have to take the InfraWorks model, and we can do some work inside InfraWorks before we even get to Stingray, and we'll probably do something halfway in between Stingray and InfraWorks, typically with Max, but there are other options. We need to make sure something that is we need to be careful of is the vegetation, particularly trees and planting, because they have high polygon counts, and it's all about the polygons, particularly when we're dealing with the lower spec machines that we're deploying to. So we need to, inside InfraWorks, just be a little bit more, maybe create a scenario inside InfraWorks. If you're familiar with InfraWorks, you can sort of roll it forward and backwards into different scenarios. Create a scenario inside InfraWorks that we know is going to be exported and created as part of the driving simulation. What's good about, there's many things good about InfraWorks, but we start to get the junctions are all built automatically for us with all the lining on there. Don't have to worry about that so much. And when we rationalize the environment, we can use this, we need to reduce the meshes. And this is a fairly complicated process, sometimes called decimation. It's a way of, and again, computer game designers will be very familiar with this, it's a way of being able to, what looks like a very highly detailed model of a BMW M3, in fact actually only has a very few number of polygons. And the process of reducing the mesh, or the amount of triangles that represent the shape of that car, is called decimation. And if you're not a big 3ds Max user, which if you, my background is more in the InfraWorks Civil 3D side, and then at the other end of the scale at the Open Driving Simulator or Stingray and the gaming engine, that bit in the middle, I have to rely on my colleagues to help me out with that sort of fixture, fixing particularly the meshes and the textures. There's some other tools out there if you don't want to go down the Max route. There is, and Autodesk products as well, Mesh Mixer and Remake and Recap, and a few others out there which you don't have to worry about the whole interface of Max, and does that work for you. Have to be careful with the textures, understand a little bit about that, and there's also Mesh Labs, open platform which you can use for fixing textures. If we choose objects in InfraWorks, and this comes down to a bit of trial and error. If we choose the right objects in InfraWorks, they come there. You make your life a lot better, a lot easier later on. So, you know, when InfraWorks has been around now for, I don't know, about 4 years in its current state, maybe a bit longer. I'll probably be corrected on most of my so-called facts, but InfraWorks has been around a bit longer than that. But the content that's inside there, InfraWorks has a large library of roads and vehicles and trees and people. They weren't designed knowing that they were going to be taken into something like simulation. So you have to, inside InfraWorks, and there's a bit of trial and error, and we could share with you some of the content that we know that works to jumpstart you if you're interested. Choosing the right content is important. Going on to the next stage, you make your life a lot easier. So now we've talked about the modeling the environment inside InfraWorks. We've rationalized it. We're drawing towards the end here. You're doing well. We've prepared everything for the Stingray environment, and this would be the point when you could use other platforms, and I was going to talk about Open Driving Simulator, but this is the Stingray Autodesk workflow, and now we have to start populating, and we can take vehicles. Now this is, there's many nuances to driving simulation. We can take the cars from Max, and there's a great, just brilliant. You can take these string lines from Max and use the plug-in Civil View inside Max to populate your city with cars so quickly. It's a great tool. You can say, right, okay, they're all going to run, these are all the center lines of your roads. They're going to have 2 cars on this side of the road, 3 cars on that side of the road. You can sort of set a density, and you will have all these cars moving around your city. And you think, great, job done. Remember what I was talking about earlier with the artificial intelligence, though? These cars are just running on a path, and they just start and stop, and they will ignore you and any of you. They don't avoid any of your interaction. So if you're using Civil View in Max to populate your Stingray environment, you have to switch collision off, and you have to have no artificial intelligence, which then you go, well, okay, it can deploy quicker, but you get the downside is that you got there's little or no artificial intelligence. Something that is great we learned about Stingray is this, it's not switchback, but there's this dual process. Can run both if your machine, and definitely recommend that you look at Autodesk's recommendation for the hardware. They run it on 2 screens. You have Stingray on one screen and then Max on the other screen. And there's a live link between the 2. Any changes you make in Max is instantly reflected in Stingray, not vice versa, just that direction. And as you move around your model inside Max, actually the virtual camera inside Stingray also moves as well. So you can see very quickly, and that's a great tool. It probably wasn't simple from Autodesk's point of view, but it's a great way of adjusting your content in one platform and seeing it updated in the other. Stingray comes with a template that is a way of representing a vehicle inside your model, setting up collisions. It sets up the environment. So that means when I say environment, I don't mean the physical one. I mean things like the lighting, the exposure of your camera, some volumetric lighting, setting up the physics of the car itself, let's say the friction on the road, the braking, turning circle of the vehicle comes with a pre-loaded vehicle. It also comes with a little basic menu system for you as well, that when you deploy, you get this great menu system. I've just realized I haven't talked about the deployment of Stingray. If you're familiar from an engineering and master planning background, you will be familiar with using a platform to visualize your model, your environment. So you'd use maybe Navisworks, you would use InfraWorks. So that means that you have to take your laptop to the client's office, to the public consultation, running InfraWorks. The output of Stingray is an executable program. It's an exe or it's on the Mac or for your Android device. You deploy to, your actually deployment is an executable file. So that means there's an issue around IP, which is an interesting one. If we get time, I'll briefly mention that. You're actually creating an executable file. So you can package that up and send it off to somebody else. And they don't need to have any special software on their computer. They can just run it. They'll have to do a virus check on it. And we're not talking about 4 megabytes of data. These are usually fairly large files, but there's enough sharing platforms out there that you can deploy to that, which is quite, that's a good way of collaborating with other people. We're nearly at the end now. We've only got, I think, a couple of slides left. So we would use I mentioned the Stingray driving simulator template. So we've got the template there already, and we've got the environment set up. We've rationalized it. We've done some testing on our own PC, and we can see it running on our development platform, but we will need to test it on our deployment platform. So if you do start to dig down into Stingray, there's some great, Autodesk has forums, tutorials on there to help you. Certainly helped us, and we're talking with colleagues in the UK and the US who've helped us here as well. One simple bit of advice is just replacing I've mentioned it before about the trees. So Stingray creates instances. If you're from a CAD background, it's a bit like a block basically, to reduce some of the load on the processor. Some other things to consider when you're developing an environment is the draw distance. This is all gaming. If there are anybody from the gaming background, they're probably thinking, what's this guy? We're really starting off in this. So the things to consider are things like draw distance. So how far away will the computer need to render so that you can see it on the screen? Things like lighting, your shadows, when do they get drawn? Exposure, your fog, which is a way of obscuring to reduce. The fog reduces what you can see in the background to reduce some of the load on your processor. So this is all the type of workflow which is not typical in the construction industry. There are people like me, we're sort of a handful of us, because we have structural engineers, highway engineers, we have planners, we have project managers, but actually guys who are developing gaming and understanding some of the issues involved with this are actually sort of fairly few and far between at the moment. Last stage, I think this is nearly my penultimate slide. So let's get it out there, let's test it, we'll put it on. As I said, it's an executable file. We've got options for our simulator. We need to get feedback from the people who've tested it, make sure it's running okay, and to get the feedback to the engineers, designers themselves. There's a whole spectrum here, just driving around, but if we can start to add point system, that if there's the interactivity that you can add inside of Stingray or inside of your game is limitless. But we are, unfortunately, constricted by our budgets. So that means that we would have to make sure that this deployment is suitable for the purpose, and that's where teams like mine come in, and where we work with our own guys and with the client to make sure that the driving simulation is fit for purpose. And I have had comments back about, hey, I'm on the simulation, the visualizations look a little bit simple. And it's like, yes, okay, but that's because we're looking at merging traffic and how to understand acceleration and deceleration lanes. And if your car looks a little bit blocky, or your buildings don't have a texture on there, is that really the purpose of it? So there's a little bit of management of expectation on the side of it. So my clock here says 5 minutes left. I think that was quite a lot of listening on your part. So thank you for your attention. So questions are on the platform. I think hopefully if you've got the app on your device, I'll be in the reception area. If you want to come and grab me, I'll happily bore you to death all about it and talk about the nitty-gritty, give you a card and we can talk about it later. And so although that says questions, the questions will be taken. We've got 5 minutes unless there's any burning questions from anybody. No. Okay, thank you for your attention, and enjoy the rest of Autodesk University. Thanks.
Cheers, Charles. Thank you. Thanks very much indeed. Charles, thank you very much indeed to you, and thank you to all of you for your attention throughout the morning sessions down here. We now treat you to a little bit of food. Please do make sure you fill in your passport details over there whilst you're out in the exhibition area. Lunch is now being served as well. We'll look to get back in here round about 2:30. We'll put a call out there in just a little while. But as Charles mentioned, if you've got any questions for him, got any questions for any of our speakers, this is the opportunity to ask them of they. We'll see you back in here about 2:30. And all, thank you very much indeed for being with us at this, the first ever Autodesk University here in the Middle East. Do hope you enjoyed and took a lot from the morning sessions. Just to give you a heads up of what's happening throughout the afternoon, we'll have a couple of sessions now from a couple of our key speakers and experts in the industry who will give you some food for thought. And then we'll take a break, a networking break, and then come back to wrap things up a little later on in proceedings. As always, if you have any questions whatsoever during proceedings, feel free to air them via our social media platforms. Just hashtag us if you can. It's hashtag AUME2016. That's AUME2016. Try and get as many of those answered before the afternoon is out. It is a day when we're asking you to ask questions, to interact, and get the answers that you've been searching for. So, where are we going next? Well, working with larger projects and an average of one architectural Revit model per 20,000 square meters built up area, learn how our architects manage to overcome the obstacles put in front of them to deliver synchronized productions in one of the recent large-scale projects included in 20-plus Revit model simultaneously. Well, we're going to be hearing from senior architect here in the region, senior architect at one of the best firms in the region, Atkins Middle East, who has a truly in-depth knowledge of integrated modeling, using Autodesk Revit as a primary design and production tool since the late 2000s themselves, 2008 or thereabouts, with a diverse residential, hospitality, and mixed-use project background in Dubai and across the Middle East. Great to have all the team from Atkins Global with us. Great to have their senior architect with us. He will be talking us through big projects, federated models, and revert work, sharing technologies and techniques along the way. Please welcome to the stage, it is Tamer Tegeldin.
Hello, everyone. It's good to be here in Autodesk University this year, although it's not very busy, as I see, but it's good. I have a presentation today about Revit, and it's very in focus about the design process that we had to use to deliver one of our projects. It's also good to mention that I have received an invitation from Autodesk almost 2 weeks ago, and that was the only time I was given to prepare this presentation. I didn't want to skip this because it's very important for me to be here. And also, I want to share a little bit of more like the practical view of the users and the day-to-day activities that we have to go through to deliver our projects. So let's get started. A bit of introduction about me. I'm a senior architect. I'm working with Atkins. And I have moved to Dubai since 2007 and started to work with Revit starting 2008. And I'm using Revit as my main productive tool for 100% of the projects that I have been doing since then. In 2011, we had a BIM award from Architect Magazine on one of our projects in my previous firm, and it was Sawari project, and I was happy to be part of the team, develop that. In 2014, I have been in the IAA convention, which was a good exposure for me to learn and to interact with experts in design and technology. And the same case was last year, in the same time, when I was in Las Vegas, attending Autodesk University there, and almost the same time now. I've also want to mention that I've spent 3 years of my career doing a BIM management job, and then I made my decision to go back and do more architecture work. And here we are. I designed my presentation as a class in the beginning, but I got to know that it will be a presentation after that, so I wanted to give it a little bit of material so that it will be easier for you to digest a heavy, focused presentation about Revit and federated model. This image is for the beautiful coastline of Manhattan in New York, which was taken by me exactly 1 year ago. And that was only a couple of days after the big show of Autodesk University, and it was a lot of fun there, and it was also a great exposure for me to be there and to speak to the expert, and we had a great fun, and the audience was more than 13,000 person in this conference, so it was huge. This is one of the slides that I liked the most, which was from the closing event, and it was speaking about how we do make impact in our design and how we change lives. So moving from this slide, I want to put down a question about BIM. Although I'm not here to speak about definitions, but I also like to have this main question, what is the main driver you do for BIM? If I ask this question 2 or 3 years ago, before the BIM mandating, it will be obviously because we want to achieve a better coordination, an efficient work process, and a better design for our projects. But which is good. Starting in 2013, the municipality started to have a BIM mandating on most of the projects that we have to deliver. And in 2015, it also has expanded. So that's the answer that I'm usually getting these days, which because it's requested by the client or because it's required by the municipality. So we want to go back to do BIM because we like to do it, because we believe it's the best way to deliver our project, and it's not just another delivery that we have to do after we finish our CAD and SketchUp thing. This is an image that being presented by Graphisoft, and the name of the software is RadarCH. The interesting thing about this image is that it has been there since 1984, and what we can see on this image is, by today's definition, by the modern BIM software, it's a BIM software, and we can see a full model of what it looks to be a house with full information about the enclosure, the shell, and the roof, windows, and all the elements. So by today's definition, we can say that BIM as an integrated modeling way of designing has been there for a very long time, and it's not something new. This is also another example of a software, and this one was developed by Autodesk, in fact, in 1998, and they call it Architecture Desktop, which, by the way, was the first software I had to use before moving to Revit. And the good thing about this approach, it's not completely modeling, but it was the first step that Autodesk take at this time to move there. And this software is still there till today, and they sell it under the name AutoCAD Architecture, if anyone is interested. And Revit. Revit, as we know, is also not new. It has been founded since 2000, and it has been acquired by Autodesk, and the first Autodesk Revit version has been there since 2004. So what I want to say is the claims that Revit is something new or BIM is something new that we have to adopt in the next few years is not actually true. It has been for a very long time, and whoever wanted to have this adopted in his processes, he could have done it already. Speaking about the subject today, which is managing federated model, first let me try to run a quick comparison between a simple project and a large-scale project. When we work on a simple project, we expect to have everything produced from the same model. Ideally, you have all the site setup, you have all the levels and grids, and you have all the information that includes the geometry and the information embedded into this geometry inside the model, and they all can live in one model. You don't have to have a big number of them, since the project does not require that, unless you have different disciplines, and then each discipline ideally will have his own model, and then they work together. But this is not the case when you work with a larger scale project. The project that I'll mention today is about 600,000 square meters, so it was a huge thing to do. And in order to keep things moving, if we can just wait here for a second, we have different definitions of the different Revit models that we have to use. The two main ones are the geometrical, are these two here. One of them has mostly all the information that you expect, plus the documentation, but we also have different types. Sometimes you have a Revit model with just the site setup, sometimes it's just for the grids, and sometimes it's only have geometry without having an actual drawings in it. And the last one will be for documentation. I will give more into depth about this when we go to the project. So here, what I want to mention is, there is a Revit model cycle, if I can say, and it starts with creation of the model itself, then it moves forward to maintaining the information that you put in and out through this model in the time of the project development. And then the last thing is the synchronization, which is very important if you have a big number of Revit models running simultaneously, to make sure that they all have the same information. For instance, if you have the grids and it's shared between different projects, you need to make sure that they all use the same source of information. You don't want one part of the project to have different information than the other one. And same thing happens for the property line and other thing. Okay, let's speak first about model creation, which is the first thing in this cycle I meant to mention. The first thing before we create any Revit model, we have to understand that term, which is level of development. And the good thing and the important thing about level of development, it gives you a clear definition about what you are trying to achieve and what you need to put into your Revit model, so by the end of the stage that you're working in, you have what it is required to give to your client, without having to over-model or add any information that is not required and adding a lot of time and cost to your project while it is not required in the first place. So if we want to simplify things a bit, we can say that level of development, 100 is more related to the concept stage, 200 is more to schematics, 300 is detailed design, 400 will be for the site activity, and the last one will be the as-built model after you finish construction, which it's also good to go to BIM forum to read more about the exact definition about it. But in the contract, when you speak with your client, you have to make it very clear and manage his expectations that he get exactly what you write on the definition of the level of development of the model, since it will be the main delivery of the project. Second thing you need to understand is the staff and the resources that you have in your project. And in my opinion, they fall under 4 different categories. 2 categories are the main ones, which is these 2 here. This one is basically the person who is capable of structuring the model and setting the strategy for the project and setting the establishment for all the, let's say, the infrastructure required for all the Revit models that needs to be there for the team to work. And the second one, which is this one, is more focused into creating geometry and doing a lot of coordination work and a lot of design decision. So these 2 works together hand to hand. And we have other 2 team members. First one ideally will be the project leader, and usually he will not need to model things by himself, but he will need to be able to open the model and to navigate through it and cut section and get all the information that he needs to make sure that the process of the project development is going in the right way. The last one will be more like a drafting person, and that's more like the people who are still getting familiar with the tool and they want to learn more. So this is the first thing that they can start with before they can jump into more modeling. Again, this is the same slide that we had before. Yeah, CAD information. When we start Revit, it doesn't mean that we will have to stop working in CAD. In fact, CAD is becoming part of the process anyway. So there is a number of occasions that you will have to use CAD and to integrate it into your processes. And I have a number of examples here. First one, obviously, if you start the project in different stage, or if you receive the project from different consultant in CAD and you want to convert this in Revit. So this is part of the process, and you have to find a way to translate all this information from being in CAD and Revit. Besides that, usually we'll have the survey, the site, and sometimes other sub-consultant or other services in your own firm, they do their work in CAD. And in the transition period, you have to find a way to get things moving and to make sure that the coordination is possible till everyone jumps in and work in Revit. Revit template. If you speak about creation of models, you have to make sure that you're using the right Revit template, and you need to spend a good amount of time developing your own template, because this is the thing that it will be reflecting in all your models. So the things that you have right in the beginning with the right information, you make sure that it actually reflects in all the models that you use. And it will be very painful later if you want to modify or change one or two families or something like that. And going to every single model and change it, it will be a very long process. So it's always easier. It saves you a lot of time to spend a little bit more time in the beginning to make sure that what you have in the template is what you require to have in all the models. What I usually put in my template is I have a standard scope box that defines the location of the building. We have number of elevation sections with the right naming convention, with the right way that we want to produce. So it works more like a guide for the people working on the project later of how they should name or follow the same sequence in the future for production. The other thing is the views. This presentation is really focused, and I know that it's targeted for people who are using Revit on a day-to-day process, so please bear with me. So for the views, if you follow this setup, you make sure that automatically, every time you create a new view, you have it right, you have it in the right location. So for example, you come here and you create the right and the new view type that you need to plan with. So you'll have one for the general floor plans, you have one for the enlarged floor plans, and so on. And that will establish a relation between the view type and the related view template. And right here in the middle, Revit actually gives you the option to define and assign a view template when you create this view. So it will automatically create the view for you and have the right properties that you can define right into your template. And the other thing here is the CAD export setting, which you have to spend some time making sure it's done correct and right. I'll not get into these details here. And also the print setup and line weights. A splash screen. Splash screen is the first thing you get to know and you get to see in your project every time you open Revit. And it gives you a good advantage because you don't have to load your project into a very heavy modeling view that takes a lot of time just to open that file. So it's very recommended to have this. And also it can be a good way to communicate the important notes and to define some of the project information right in the beginning of the splash screen here. This is a good example of one of the areas that defining a template for your project can save you a lot of time. The sheet that we see here is all coming in Revit, and it's more than 189 schedules just to get this in one sheet. And if you decide to keep this as a separate template that you can use in more than one project, you can invest more in your time that you have done here, and you can use it for a big number of projects, not just keeping it limited to the budget of one of the projects that you have. So that's actually a good way of building your template. Second thing I would speak about in this cycle is the model maintenance, which is very important because the Revit model is very different from the old CAD method. The Revit model is the source of all the information that you produce, the source of all the information that you eventually will deliver to your client and will send to site. So if you're not maintaining, if you don't have a good process of maintaining the information that you insert every time to your Revit model, you are risking that you have a bad information. So you will not make a good use of your Revit model, even if you're using BIM. Some of the examples that we have, and actually I have it for a long time now, it's the main elements and the main components that we use in the project. And it's good to define it in a separate template, in a separate graphical representation, so the people working on their project, they can open it and they can select it and they can see what they need to insert. Because by the end of the day, any model, any architecture model will contain the same elements, which is walls, floors, windows, and doors. So by standardizing all this information and make it available for your team in different projects, that gives you an advantage of having all your project synchronized properly. The same thing happens for the door, it's the same idea. And the next one will be number of other Revit families, which, as we see here, there is a plumbing fixtures, there is streetscaping, and there's some curtain walls that we use mainly to produce our facade. This is the last thing I will mention about this setup, and it's the Revit links. After you have your Revit links set up, the first thing you need to worry about here is a display setting. And I find many people who's more into Revit, they prefer to do a lot of custom settings for their view and a lot of by linked view, which is very difficult to manage later. So my recommendation here is to keep everything by host and then to put all the information that you have to be modeled in 3D. So even if you're opening it from the same model or opening from a linked model, it will always show the same way. And you have to develop a links diagram and share it with your team so they all know which links they need to insert for each part of the project. The other thing is the reference type. The two reference types that we have for links is overlay and attachment. And I always prefer to have it an overlay and to have a direct connection between the links and the Revit model, because that makes it easier to manage. If you have it attachment basically means that any sublink that you have in any of your Revit model, it will automatically go to all of your models. So by the end of the day, it will be more difficult to manage. So always keep it to overlay. The last thing in the cycle is the model synchronization, and that's where we're going to discuss the project that we have as a case study. First thing, we need to understand work sharing. Work sharing in Revit means you can work in a team. And the work sets is a primary tool that is being developed by Revit that allows this functionality. So the first thing you need to do is, first of all, select a project and then enable work sharing, and then set up work sets, and as simple as this. The next slide, we will see the different work set types. We usually have 4 types of work sets in the project. First one is the custom one, the one that you can create, and you have to line it up with the way you model and the way your design works. And think about your team doing that, because you want to define it in a way that every team member that you have carries on the responsibility of a specific area of the model. So by having the work sets organized in a way that works with your design, it will allow a direct responsibility for each one of the teams that he can take the ownership of this specific element and continue to develop it. There's also a good point here, which is the active work set. These are actually the main work set that has to be there from beginning, even if you're not defining what is the custom work set that you have. First one is the active work set, which the work set has to be there, and it has always to be the active work set, and that reduces the risk of any element that you create new. It has always to come to the active work set. And then you have the links, the levels and grids, which always will be locked in the project unless there is a major design decision happening by changing them. So put it there and keep it locked. The second thing is the project standards. And this feature in Revit is usually not being used a lot by people, but it's a very efficient way of controlling your project and the standards that you're using in your file. So you don't want anyone in the team unintentionally go in there and change the setting that you have spent time with your team to develop to make sure that they are all correct. So what I would recommend and what I will do is keep everything in the project standard, because there is no reason that you need to change this unless it has been changing for all the models in the project. It should not change in one of them. So when you end up the production, you have different projects with different looks and different configuration. You want everything to look the same. And if you have a preference to show it in a different way, you have to communicate this to the team and agree on it, and then we can apply it everywhere. So that's a good way for you to keep things in shape. Yeah, families, it's exactly the same way. It can be a little bit more open, but I also prefer to have it locked. So the decision of changing any of the family, which is part of the project, should be managed. And the last one is the views. Workset gives you the ability basically to give separate view for a separate user. So if you have a team and you already have assigned him to work on this view. You can put him as the owner of this specific view or the set of views that he's working on, and you can always know that he is the only one changing this. So you don't have to lose liability on the responsibility of who is changing my view and who is messing around with mine, because that's very common to happen in Revit, especially if you have people starting for the first time. Okay, now I'll move to the case study, which is a large-scale synchronized model, and it's a mixed-use development in GCC. As I mentioned before, it's a huge development, and we had a very limited time to develop the entire set here, and the built-up area is about 600,000 square meter. So if we speak about the model definition, the first part that we have here is parcel number 1, which in the main function here was a residential part. And then we have the hospitality, which contains hotel and service apartment both sides. And then we have the big part, which is the main function of the project, which is a serviced, it's the offices and the business plaza. These are the views that we have created, and you can imagine the amount of work required to achieve the full site in one view for each level here. It takes a good amount of effort because collectively you see the work of the entire team shown in one floor plan. It's, I will not say it's easy process. You have to maintain your model. You have to make sure that it's always being modeled simultaneously in the right way with the right standards. Otherwise, you risk to have different zones with different look. Here are other floor plans. And then that's the top view. And these are the floor plans that have been produced directly from Revit. Sometimes I have to say that it has been produced from Revit because some people still don't believe that Revit is capable of producing a construction set of drawings. So yes, it is developed from Revit. And this is the overall look and an image for the entire developments that we have, showing all the parcels, all architecture and structure discipline besides the landscape. And this image has been produced from Revit with no other effects. It has not been photoshopped, has not been rendered. So it's quite good to show you the scale and the amount of work that we had to put to achieve this amount of density. And each single part of the project has been developed in a separate way, matching with the design intention that we have here. So for residential, we have this design intent that we want to drive the elevation based on the floor plan. So we have something like a Lego that we play with. So we end up having small components that we put it in certain order. And it was a challenge because by the time you're doing the floor plans and you get the client to accept it, you go back and you're not happy with the elevation. So you have to keep going back and forth. But this is actually the beauty of doing this in Revit. If you do it in SketchUp and CAD, as people prefer to do, you will have a complete disconnection between what you draw in a floor plan and what you draw in the model. And when you try to put them together, it will be a complete mess. Second part here is hospitality. This was done as a core and shell, so we have the core and we have the shell surrounding it. The same thing for the business plaza. Again, this is the full image. I like this image a lot. That's why I show it again. Okay, just a quick recap on the Revit links that we have discussed in the beginning. These are the different types that we have used to achieve this Revit model. And these are the team definitions that we had. Speaking about the actual team working on the project, we have average of 16 architects working on the same time to deliver this job in a very short time, which is almost 3 months. And it was a major stage to deliver. And to make sure that they are all working simultaneously and no one is interrupted and no one is depending on someone else's work to finish his job was a challenge. And speaking about the files itself, this is how it looks like. On the top here, we have the main Revit models that we have used. We have 5 parcels, so we have 5 different Revit models, and there's an extra one which is only for documentation, and we've used the last one only as a placeholder where we collect everything together to show and to produce our overall floor plans. The next layer of Revit models here is they are 30, and as it's written here, they are links, so they only have geometry in it. They didn't have a single drawing directly from it, but collectively they work together to produce the overall model. And then we have two sets of Revit models, one for the details and one for the areas. And first of all, the areas, we want to have it as a separate Revit model so that we can track the different versions of the areas that we submit to our clients. So if we come with a concept submission and we want to give him an area schedule, we want to keep this area schedule locked on the same date. We don't want to be surprised next time that we open our Revit models that we have a different figures because we have modified one wall from being 200 thickness to be 100 and stuff like that. So we keep it separate and we use it and we draw it using an area boundary. So we use the Revit models that we have as a link and we start to draw everything. And the next time we have another submission to our client, we keep the old one as a backup. So if we want to compare the old and the new one, we can put them together and have this. Similarly, but not exactly similar, is the details, because sometimes you want to do a details work in 2D. And doing stuff in Revit doesn't mean that you have always to model everything. There is a big capability in Revit that you can do a lot of 2D stuff. In fact, the argument is doing it in 2D or 3D, not to do it in Revit or in CAD. And you have to be wise enough to decide that certain details has to be done in 2D, so it doesn't have to rely all the time on the model, and every time you change it, you have to go back to change your details. So keeping it separately, I think it's a good exercise. And then, obviously, the big number of CAD files that we had, some of them was based on this diagram, some of them was from the previous stage, and the rest coming from other disciplines and other services. Here, this is the strategy that we have developed to deal with our Revit, with our CAD links. And thinking that you have 50 CAD files that you want to use in 36 Revit model and starting to insert every single CAD file to every single Revit model, it's a big headache. Plus, you can never guarantee that it will be synchronized. It will never guarantee that it comes in the right place. And we do in fact rely on CAD information to be presented in our final production. So there is no way that we can risk not having it correct in the right place. So what we have come up with is this process, which basically we have an empty Revit file with no template in it, just number of views, and we link every single view, every single CAD file to this Revit link, and then we take the Revit link itself and we link it to all our models. So we have only one source of information, plus every time you get to update anything, you only update it here and give it the same name and make sure it comes to the right place. And you don't have to open this Revit link or Revit model at all. So that was a very good way of taking control of this process of dealing with Revit links. Again, as I mentioned, Revit link can be a transition from previous stage or a transition from an old consultant that used to work on your project, or it can be an information that you need to take from a surveyor or from other disciplines that you must insert to your production. And you don't want to go back to model everyone in the other disciplines who is not convinced to do their work in Revit now. So this is how we do it. This is an example of a standard practice that we do for the grids. And having a site this big opens a chances for a risk to have different grids in different files. So in Atkins, we always have this, and we always produce one single file, and this is a source for architects, for a structure, for everyone, for the grids. And if there's any update, we update it here, and then every single model has this grids. He has it as a copy with monitor. So by the time you change anything, you need to do the coordination review, and you will be notified that there is a new thing that has happened, and you can go back to update it. So you need to make sure that this is happening. And there should be someone in the team who makes sure that all the time this kind of coordination reviews are being done and it's not left over. So you make sure that it's actually reflecting the right information in every single model that you have. Similarly, the definition of different zone, different parcel for the property line. And in case of any change, you want to do it in a separate 2D format, and it will be reflected automatically in all the views by using linked view. Here I will just highlight some of the main links that we have used in this project. First one have a service tunnel, which is something that was out of our scope, but we had to deal with it, especially the structure guys. They had to put it into their consideration. So we had to take the as-built drawing and convert it into a model and put it there, and it was available for everyone in the team to use it. And the two things here, sorry, I missed the previous one. This one here reflects the podium where we have most of our parking spaces, but this is not one link. This is divided into 1, 2, and 3 different links. So what we see here is just the overall image of how the strategy of our links been working. And here we have the 2 main elements in our model, which is the core and shell. In the core, we keep most of the most of the structure elements and most of the cores with the vertical transportation elements happening here and the slabs. And on the other hand side, we have the shell, which is the facade and everything surrounding your building. So again, this is not one link. This is, for instance, if we start by the shell, we have big number of links for the residential. We have 1 link for the facade of the hospitality, and we have 1 link for the facade of the 3 other parts, which is the offices. And there is, even if they are a little bit bigger than usual, we want to keep it all connected in 1 Revit model, because there are certain elements that you want to synchronize, and it's easier to have it in the same model and to make sure they are synchronized rather than having to open different. So this kind of decision and analysis you need to do right in the beginning when you make the first initial plan and how to do your project. Similarly, the cores here, we have 1 core file for the residential, another one for the hotel and hospitality in general, and we have 1 for all the 3, 4, and 5 parcels, and we manage between them by having different work sets. This is the final render image. It's not produced from Revit, but it's using the full Revit information that we had in our model. So we submit this, and they came back with the rendering based on what we give them. So nothing here is being modified in 3D Max or anything. So that's it. Hope you like it. Thank you very much. Thank you.
Thanks very much indeed. Thank you. Should I take that? Thank you. Bless you. Tamer, thank you very much indeed to you. Thanks to you for your insight, all the team from Atkins Middle East as well. And so we come to our final presentation of the afternoon. A quick reminder, as always, as we have done throughout the day, if you'd like to interact, if you'd like to ask us any questions, there will be an opportunity to do so after this next case study. But equally, if you want to do so right now, you can do so on social media. It's hashtag AUME2016. Hope you're taking something from proceedings throughout the day. As I said, big thank you to Tamer, to all of our speakers. And thanks in advance to our next speaker, because we've got 1 more project case study for you before we break for a networking session outside and then reconvene for the final session of the day. This one is entitled How BIM Helped Facilitate the Fast-Track Delivery Process of a Theme Park Development Right Here in Dubai, one you might well have heard about. It's going to be delivered by a man with 15 years experience in the business, both here in the UAE, it's Australia, and back in the UK as well. Structural background, but also learning to manage the multidisciplinary CAD teams for Dubai and Abu Dhabi, combining structures, MEP, and civils along the line. Extensive Revit structure knowledge and a development of BIM management skills during those 15 years of experience to date. He is the Associate Buildings Environment from Oricon Group. He is Daniel White, and he's here to present Dubai Parks and Resort Motion Gate case study for us here today at Autodesk University. Daniel, over to you.
Hi guys. So I'm here today just to tell our story, which is MotionGate and how we brought it to life. So the learning objectives for today, we're going to take you on Oricon's journey, how we applied BIM to produce this major project, and then finally, how we became future ready. At Oricon, we've developed a culture whereby we start each workshop or each meeting with a safety moment, and today's no different. So normally we ask the attendees if they've got any examples, but today I've come pre-prepared with a couple of MotionGate related ones. So here we have Sabana, our resident engineer, in a customized pink hard hat. And then we also have the Contractors Excellence Award, whereby they achieved over 3 million man-hours without any serious incident, which is pretty impressive on a site this size. So on to MotionGate. At Oricon, we talk about bringing ideas to life. And in this instance, bringing a theme park of this magnitude is one of the most literal interpretations of that. You can see the actual MotionGate site here, which the park was divided up into several sections. So down at the bottom, we have the main entrance and the gate, and we have the Studio Central area running through the middle. We then have the Sony Pictures area out to the wide right. Top right-hand side, we had the Smurf Village. To the left-hand side, we had the Zone 5. And then finally, we had the DreamWorks building, which is right at the top and was the main building of the theme park. So how it all started. I joined Oricon back in November 2013 as a BIM manager. Back then, we had a very small team of no more than 20 colleagues in the office. We had a facade team, structural team, and MEP team. And we were currently working on Madinat Phase 4 and the Al Ain mixed-use development. On Boxing Day 2013, the management received a phone call from a client saying, would we be interested to design a theme park in Dubai? I always remember, it's a bit of a standing joke in the office because I was asked to be ready to be on a plane over to LA with a moment's notice. And the joke in the office was, surely it must be Al Ain and not LA. But anyway, before we knew it, we were on our way, residing in Pasadena, Los Angeles, for 2 weeks for the client briefings. We entered a whole new world. It was a far cry from your traditional consultant engineering offices. The closest I can link it to is like going into like a Google workshop or something. It was a massive warehouse. There was guys with bikes. It was a whole new 3D world. It was, it was incredible. And our main task was to produce fast-track engineering solutions and a blank canvas so that these creative or these artist types could do what they needed to do to create all the internal theming. I remember in that meeting, one of our directors promising that we'd have the piling rigs on site within months. And after only 4 months, we had those piling rigs on site. And within 1 year, we were erecting the first of 5,000 tons of steelwork for the main DreamWorks building. Now, to many, this image here may seem a little confusing. It's not an aircraft hangar, and it's not artistic license by the BIM guy. But whilst over in LA, I was tasked with trying to place as many A380 Airbuses into the main DreamWorks building. And the main purpose of this was just to showcase the sheer size of this building to the many stakeholders who were about to start working on it. I'm sure if I tried a bit harder, I could have squeezed a couple more in, but I did my best. So on to the overview. I think most people will have seen MotionGate or heard about MotionGate. If you haven't, as you head out of Dubai and your way to Abu Dhabi, you won't fail to miss it on the left-hand side. These numbers here, when you talk about the estimated costs, the size, the number of visitors, and then finally the planned opening, and most importantly, which is due any day now. So when we first started on this project, Oricon actually instigated the hiring of a local drone company just to fly a drone over the site in its entirety so that we could see where the project was up to, with a couple of buildings having actually had the foundations already put in, and to show to the many different stakeholders and collaborators who are about to start working on this project what we're embarking on. So this here is the very first video that was actually produced when we started on the project. So straight away there, it gives you some indication of the actual size of the site. As I mentioned, there's only a couple of the smaller buildings that had the foundations in already. I think with hindsight, what we would have liked to have done is flown it more regularly than on a monthly basis and actually compared the plan versus the actual and done some coordination as well. But it was so popular anyway that the client decided that they were going to run with this on a monthly basis and did so throughout the entirety of the project. And then since that moment in time, and internally, we now have our own drone pilot who's got his license, the consent, and for all our projects, he flies a drone and does this on a weekly basis just so we can see the project, how it evolves. Key milestones. So as I mentioned, on Boxing Day 2013, we got the call. We then headed over to Los Angeles in early January. The piling rigs were on site in April. And then from this timeline, it looks as if 2015 was a pretty quiet year because there's nothing up there, but I can assure you it wasn't. And then finally, with a confirmed opening during December 2016. So mobilizing the global team. We were doing fast track, and so we had to do this very, very quickly. As mentioned, we were a very small team here in Dubai. So we were relying on our colleagues around the world. We had help from our colleagues in Australia, in Bangkok, and in our Vietnam offices as well. Gensler Architects were the ones who actually employed us for all the engineering services. These included the infrastructure, civil, facade, mechanical, electrical, and structural. We've also since found that one thing that's been really useful for all of our projects ever since this moment in time is to have what we call an engineering interface team. And that is a team of the leads, the discipline leads, who actually are based in the architect's office just to help with the transition. In this instance here, we're talking about architectural models, theming models, we're talking about the engineering models. It's a great way to just have this transition between a lot of complex geometry, a lot of complex modeling, and they just relay that back to the engineering team. So it's something that worked really well, and it's something that we've adopted ever since. This picture here, the top center one, is Oricon colleagues over in Los Angeles in the Gensler office, doing what they do best. And then the top left and right are the Oricon BIM team. We try to celebrate every key milestone with a BIM team lunch or the like. And then across the bottom, we just got some of the key members of the team who worked on this project from both Oricon and from Gensler. The team that never rests. This is sometimes quite applicable here in the UAE with the many hours and the project deadlines. This slide here, though, is actually referring to the VDI, or Virtual Desktop Infrastructure. Now, this is a server that was based in Sydney that everyone around the global team could actually tap into and work on the Revit models in real time. As you can see here from the slide, the guys from America would be online. As they started to drop off, we'd then have our colleagues in Australia, and then Vietnam, and then Thailand, who are doing the structures, ourselves here in the UAE, and then finally the South Africa team who was taking care of the infrastructure. And this would go over a 24-hour period with LA coming back online at the end. So without this, we would have really struggled. We were doing fast track, and it was the best way for, we had over 250 guys working on this who could tap in and work on the models in real time. And it just completely sped up the process and the delivery of this project. As mentioned, this just demonstrates the sheer collaboration effort with a number of continents, the locations, the hours, the employees, and then the BIM models, and that huge number of documentation. So on site, there was 32 buildings in total, with 27 key rides. The lion's share of the modeling was done by the architects, as you'd expect, which was Gensler, for their theming and their core and shell. And then we had the MEP models, and then the structures bringing up the rear. One of the keys to this project, and to most projects for guys in the audience, I'm sure, is to make sure you manage the size of the Revit models. Even more so when we're working on the VDI, or virtual desktop infrastructure, and you're linking in a host of series of models, and you're doing your coordination and your collaboration. So the design principles and the implementation of BIM. One of the first tasks for our BIM team was to actually start setting up these white papers, or costing options for the quantity surveyor. This is a structural sample whereby we were comparing the piled foundations versus the pad option. This was just a case of knocking up a very quick pre-concept or concept model by the BIM team, and then relaying that information to the engineers who would produce this report, including a summary and recommendation, along with the extracted material and quantities, which would go to the QS, who would then compile this, and it would finally be presented to the client so they can make an informed decision about the best way forward. So it's something that we adopted for this project and have used ever since, and very effective. So for those of you who haven't actually worked on a theme park before, there are two types of designers. There are the architects and the engineers, such as ourselves. And then you have the creative types, or the set designers, who produce fabulous pieces of work, such as this. And then this. And then finally things like this. So our plan was to try and decouple the design so that we could create a blank canvas for these set designers so they could work. This is a great example. This is the DreamWorks building, which was the main building on the park. Hopefully you can see here, but the intention was to use these long span steel trusses in the roof to free up, to make a column-free interior layout. The MEP was also up in the roof truss zone, and we used modular construction for this as well, so it was a great process. And it just meant that the guys had a blank canvas, and whereas we were working to one time frame or program, they were working to completely another one in advance. So it meant the core and shell could still be carried out, and then the interior fit out would follow thereafter. As I mentioned, at Oricon, we talk about bringing ideas to life. I think this slide here is a great example. To the right-hand side, we have a picture that was taken a couple of months ago on site. And then we have the comparison of the central picture there, which is actually the BIM model, which is the architecture and the structure combined. And then to the left-hand side, at Oricon, we always try to encourage our staff out onto site where possible. In this instance, we were also very fortunate to have a site supervision team throughout the construction stage, which was great for them. Many of our guys in the office who worked on this project always fondly remember the day one of our engineers said, "How do we model a mushroom?" is actually a pretty seamless link from the BIM model. When you export the geometry into the analysis software, engineers do their analysis, and then it's re-imported back in. This slide here is a great example whereby we've got that analysis model, we've got the engineering models, the architectural models, the artist sketches, and then finally the pictures from site. Now, the Ghostbusters building was one of the big 5 boxes. The design principles were pretty similar to that of the DreamWorks building, whereby we had the trusses in the roof with the MEP located up there. This worked pretty well. There was still a lot of coordination involved, particularly when you bring in the theme in and the interior fit out for the architecture as well. And there's just a small blow up there of the type of coordination that's involved with the theming envelope around the outside. I was also fortunate enough to visit the factory with our in-house facade team and also Gensler Architects. Someone in our office came up with a fantastic idea, which is the top center picture there, whereby we used prefabricated floor panels and installed them vertically for the building envelope. The beauty of this was that they were readily available, produced here in the UAE. They're very, very cost effective and very quick to erect. I'm not quite sure what the relevance is of the lion there, but it was just a picture that was taken whilst in the factory. And then finally we have some pictures from on site where you can see the wire meshing that goes into the theme in, and then that is sprayed with concrete. So all good projects require good planning up front. At Oricon we try to do the same. We always develop a BIM execution plan that the project team can execute. For some of our most recent projects, we've actually been the lead consultant, and whereby we've actually produced a BIM management plan as well. Engaging all participants or stakeholders as quickly as possible is crucial, and ensuring that you receive the most reliable and up-to-date information, along with sharing these models as frequently as possible. And then finally, just to make sure that you continue to maintain the BIM execution plan throughout the life cycle of the project. It's not something that you set up at the start and then put to one side. We've also developed our own standards, as per a lot of consultants, whereby we have our templates, our families, our manuals, etc. And we developed our bespoke tools, such as the Clash Matrix there, which is that image in the bottom left-hand side. And then finally, recently, we started using Yammer. For those of you who don't know Yammer, the best way I can describe it is it's very similar to Facebook, but it's for corporate. And it's a great way to reach all your company experts around the world they can come back to you and answer questions on a host of different topics. So like all projects, we always have a lessons learned. This was a major project for Oricon, and we have a major project steering committee who always insist upon a lessons learned presentation at the end of every project. The lessons learned that I'm going to talk about here are predominantly from a BIM perspective. So the VDI. Now the reason the VDI, or virtual desktop infrastructure, was a lessons learned was mainly because of the bandwidth issues that we experienced here in Dubai. So for the rest of our colleagues, it was fantastic, but for us, it was a little bit slow. So when we got to the end of detailed design, we actually had to switch this off, and all the production for the construction stage was done here in the UAE. Clash detection, something that we're finding clients are very hot on these days, and it's something that we could have done a little bit better on this project. It's something we've really worked on using Navisworks and our clash detection matrix as well. Shared coordinates. For our structural team, this was really important. We had a lot of pushback from this, and it's something that we really must insist upon for all our projects going forward, that you get this locked in from day one. And then finally, automated processes. There's lots of different smarts in the market now that have really quickened up our delivery when it comes to production. Team improvements, we talk about dedicated management, such as a model manager and a document controller. When you're working on a project the size of this, you know, sometimes it's a bit of a luxury to have those dedicated guys, but it's well worthwhile. And then just getting your team structure and the workflows right from day one. As I mentioned, we also had a lot of assistance from our teams in Vietnam and Thailand, and also Australia as well. And it's worth just, you know, understanding their cultures, understanding how they do things might be slightly different, and also building those relationships as well is really important for the success of the future projects. And then positive outcomes. So I've mentioned the video a lot, but it was definitely a positive outcome. And the reason for that was, without it, we had a very small team. We simply couldn't have produced everything here from day one. So with everyone tapping into that and producing the work that they did, that was pivotal to the success. Daily catch-ups, just via Skype or link or even email, just to check on the progress, make sure everyone's got the necessary information. And then combined quality assurance. Again, this is something that clients are getting really hot on and something that is really important and just should be mandatory. And then finally, the engineering in Asia. The original scope was just for the BIM team to help us out, and then we actually extended that onto the engineering, and that worked really well with the guys working together and delivering actual packages. So it's always nice to have some positive quotes at the end of a project. I think some of you in here may be aware of John Hainsworth, who's Oricon's digital leader. He's quite well known and does a lot of talks at Vegas, etc. And then we have one from Phil Jafarian, who was Gensler's project director. A lot of the guys who were in the engineering interface team over in Los Angeles would always tell us about Phil. Would on a daily basis, he was a little bit of a joker. He would come up to them and say, you know, are you having fun yet? I think the answer very much depended on the challenge at the time, but generally it was always good fun over there, so I'm told. And on the back of the success of MotionGate, we won further theme parks. We also increased the size of the BIM team as well here in the UAE to help deal with this. Although we did have help from Ho Chi Minh, Vietnam, and also Bangkok at the start just to get things off the ground. And again, we focus very much on coordination for this project. This slide here indicates the growing trend for theme parks here in Dubai. Obviously, Dubai Airport is one of the busiest in the world now. There's a lot of visitors, and I think they're trying to capitalize on that, attract lots of young families. I'm not sure how many more theme parks this city can hold, but I definitely think Oricon are well placed to assist further if required. And since then, we've had even more opportunity to hone our BIM skills with another theme park. And as mentioned, the coordination is extremely important for a lot of our clients now. They're asking for clash-free models all the way through at different design stages, so we've really had to up our game there. We've also tried to improve the client experience as well with our augmented reality and our virtual reality. And I'm just about to play you a video now, which is one of our models. I've been informed by the team that it is clash-free, so I hope we don't spot any. So the purpose of this video is just to sort of highlight what goes into a theme park and the size of the models. This here is it's a structural model, it's the MEP model, it's the architectural model, and it's the theming model as well. Again, the same design principles whereby all the MEP being raised into the roof as well, just to clear that interior space has been adopted. And it's worth pointing out as well, hopefully you can see it, but where we have those trusses there, halfway through the design, the structural team actually decided to flip the diagonal members, meaning that our MEP team had to go through the coordination process all over again. So they knew this project very, very well by the end of it. And as we start to move under the actual roof truss zone, you get to see the actual scale and complexity of some of these models that we receive and are working with, and the coordination that is required. Again, it's just a case of trying to keep these model sizes down, particularly when you're collaborating and linking in a host of different models, which is not always easy. So Oricon, here and now. One of the big things or hot topics that we're really finding is, seems to be getting a lot of headlines at the minute, is the HoloLens. So it's not actual matter, it's more like a beaming of light. It's completely unattached with no wires or connections to phones or anything. And again, it supports augmented reality. This video I'm about to play now is a video that was filmed in Oricon's Sydney office. And it is a CFD model analysis that took place. That coloured tape you can see there is just the flow of air movement. And the next tool, or next thing that we're also looking into, is VisRT, or visualization in real time, which is real-time 3D graphics. Again, we talk about bringing ideas to life and also changing the way we communicate. This video here is again from our Sydney office in Australia. And what they're doing is they've modeled the office itself, and with a handheld controller, they're actually moving pieces of furniture around the room. And the purpose of this is just to demonstrate that this is where the industry is heading. When it comes to client sign-offs, clients are going to be able to strap on a pair of goggles and actually with a handheld controller start moving things around, whether that's partitions, whether that's light fittings, or anything like that. So this is just a snapshot of where I believe that, and where I think the industry is actually heading. So you have it. So just when you think you've got your design locked in, we're actually giving the clients even more opportunity to make further changes, but it's pretty impressive stuff anyway. And then the next big challenge. This is the last video I'm going to show you today, I promise. Unfortunately, due to client NDAs, non-disclosure agreements, I can't really elaborate too much further. But hopefully one day, either myself or one of my colleagues will be invited back again to talk about a case study on this fabulous project.
The world's 5 leading architectural firms were invited to compete with one goal.
But we are looking for a tower and for a monument that adds value to the world. A monument and a tower that celebrates the world one more time. I think these buildings and these towers and these monuments, I think they enrich these societies, but they're also celebrated by the world. So our emphasis is that a city like Dubai, where there's so much diversity and there's so much celebration, we wanted to do all that, but with absolute elegance. We want elegance, technology, engineering, beauty day and night. Calatrava, I believe, have done it and have done it very well.
To work in Dubai and to work for such a special project is an enormous honor for all of us. To work also with Emar makes it even more exciting and more demanding. And as an artistical achievement, is inspired by the idea of welcoming people, of sending a signal to not only to the neighbors, not only to Dubai and to the Emirates, but to the whole world. It's our ambition to create infrastructures in the tower who facilitate the everyday life of the people, who makes them very familiar with it, that they love the tower, they use it. It is the center of a new city. And at the other side of a combination of geometry, mathematics, and deep sense of understanding of architecture in the most classical way. The tower as a technical achievement will be the addition of the most advanced technologies that you can use today. I understood technology as a vehicle to beauty and technology as a vehicle to art.
The tower rises in Dubai Creek Harbour, Emar's latest mini-metropolis at the Cape of the Creek, Ras Al Khor, in the heart of the city, yet at one with nature.
I believe that adding that piece of art while using the most advanced technology, the most advanced mathematics and physics and engineering and material and science, I think beside beauty, I think you're adding so much more and gifting so much more to our beautiful city, to our country, our people, our visitors, and the whole world as well.
So yeah, exciting times ahead for all of us involved, and Dubai as well. So to summarize, from the BIM team's small and humble beginnings, to how we grew the BIM team and delivered this wonderful and fast-track project, and then finally to becoming future ready with exciting new tools and even bigger challenges ahead. It's great fun preparing this presentation and looking back on these memories. It's funny how some of the challenges just sort of fade into insignificance, and all you're left with is the great memories and the great outcome. And MotionGate was certainly no different. If you do have any questions, please feel free to give me an email, send me an email, or maybe one day I might see you on MotionGate. Thank you very much for your time. Thank you very much. Cheers. Thank you. Cheers.
Huge thanks to Daniel. Our thanks to he for his case study presentation. Our thanks to all of our speakers down here at Autodesk University Middle East 2016. Right, we are going to break again. It's a networking break. So networking will be taking place outside in the pre-function area and the forum area. So do head on out there into the exhibition proper. Make sure you speak to all the sponsors. Got any questions for Dan, for any of the other speakers, this is your opportunity to ask them of they. We'll be back in here round about 4:30 to wrap things up at the plenary. So do join us here for one final session. But for now, do break out for a little bit of networking outside in the pre-function area. We'll be back shortly. Welcome back to one and all. Thank you very much indeed for joining us for the final session of the day down here at the inaugural Autodesk University Middle East 2016. Hopefully you've taken something from the day thus far. Hopefully we can learn something from your experiences. And to that end, if you haven't already downloaded the app, then please do it now. Make sure you fill in that passport. It could be worth your while because we've got 2 Microsoft Surface Pro 4 tablets to hand away before we all vacate this room a little later on. So if you haven't already, please download the app, fill in the details, fill in your thoughts as well. We'll give you another opportunity to do that a little later on. We do hope that we've been inspired at some point during proceedings, inspired to ask questions of us via the social media platforms on the app, inspired to ask questions of our numerous speakers throughout the day, inspired to continue asking questions about some of the things that you've heard discussed on this stage and out there in the pre-function area. And we're going to leave you with a little inspiration right now as well. Not only in making your own future, but showing what future-looking organizations are doing right now in enabling a new area of connectivity, connection, and technology at the same time. There is one company here in Dubai, one brand, that is a supporter of today's initiative, and it is, of course, the team at Dubai Design District. We're going to hear from one of their representatives in just a few moments. An individual who's responsible for managing the end-to-end implementation of D3's smart services and its initiatives across the city. She ensures that such initiatives are aligned with the overall strategy for Dubai as laid down by the Dubai Smart Office. She has an MBA, an honors MBA from the American University of Dubai with the BA in Computer Science honors from the American University in Sharjah. She's here to talk to us in the final session of the day, representing Dubai Design District. We are pleased to have with us here the Program Director for Dubai Design District's Smart City Project. Please welcome Ms. Hanan Houer.
It's really exciting for me to always share this project that I'm working on. It's a very close project to my heart, very challenging, but very exciting. And I'm really excited to share it, and I hope that some of my excitements rub off. So let's start. So to start with, let me introduce Dubai Design District. Dubai Design District is a new business development, 21 million square feet of mixed land use that is mainly catering for the design industry. It's an area that is literally trying to provide the complete value chain for the design industry, and there is luxury, art, fashion, and in all segments, whether it be lifestyle design, automobile design, technology design, experience design, and so on. So with this inspiring development coming up, and alongside another initiative that is started across Dubai, which is the Smart Dubai strategy. So in March 2014, His Highness Sheikh Mohammed bin Rashid, the ruler of Dubai, actually announced a strategy for having Dubai the smartest city in the world. And that's by becoming basically the happiest city in the world. So looking at that initiative and taking more details about it, I'll go back and say why Design District also took upon this project. So the basic mission and vision of the Smart Dubai is basically utilizing its resources, utilizing its infrastructure, utilizing its technology that is there to basically provide a seamless, safe, impactful experience for all its visitors and residents, and basically create a better quality of life and hence create a happy city. So this is the basic aim that they have trying to achieve through creating the Smart Dubai initiative. And what they did is they looked at it and what we're trying to achieve is creating these services or these initiatives across 4 main pillars and then 6 dimensions. And the pillars are basically being efficiency. So I'm creating some sort of efficiency in the way I do business, in the way I conduct my life and interact. And it should be seamless. It shouldn't be something that I work extra for it. It should come easy to me. I shouldn't have an extra layer of things that I need to do or technology. It should be very seamless in the way that it's being used. It should create safety. Safety is a very major thing that Dubai looks at. So safety is always an aspect they look at. And of course, it should be impactful. So it should create an impact. It should create that value that it creates. So what does this have to do with Design District? So Design District was launched in 2013, which is very close to the time that the Smart Dubai strategy was launched. And when we looked at it, it was like, look, this is a really good opportunity. We are a green field, and we could take that as a pilot. We can try out everything that we want to achieve in the city and see how can it work, and then cascade it back to Dubai. So that's what how Dubai Design District got involved. So we were being selected as a strategic partner to the Smart Dubai strategy, and we're basically now a greenfield pilot that works very closely with the Smart Dubai office and other government agencies, as well as initiate our own initiatives in order to make this district the smartest district, and then see how that goes back and what does it mean to Dubai overall, what does it mean to the UAE, and even internationally, how does this affect? So what did we want to do? So when we looked at it, we really did a lot of homework. We did a lot of benchmarking, understanding what is smart city, how do different cities look at smart city, what initiatives they have deployed, why are they deploying smart city, what does it mean? When I say I want to create happiness, what does that mean? So one of the things that we were clear on from the beginning is that what we want to do is create a holistic approach in the way we do it. So you can create or deploy smart initiatives, you can create or deploy smart technologies in different segments to create different values. Could it be in mobility, transportation, it can be in the way we live, it could be in the health sector, in education and so on. So we wanted to take this and say, no, district will look at it as a holistic approach. How can we create a very much seamless, integrated community that is smarter in the way it deals with things? So then we looked at the different dimensions. Our dimensions is also very similar to the European dimensions of smart city. We look at 6 main dimensions. We look at economy, we look at environment, we look at mobility, people, living, and governance. And what we want to say, as again, is the way we looked at it is how do we interconnect all of these things? How do we create services in each segment, but at the same time create this holistic approach in the way we provide the services? So the next thing that we've done is identify who are we trying to target. What are the different segments that we're saying? So now we understand that we want to create a value. We want to create happiness. And it's across 6 dimensions, which allows us to focus our effort as well. So what we looked at it is, yes, so these services or initiatives or these smart elements that we're trying to do is going to touch at the number 1, us as city operators and developers, how it's going to affect us in decision makings and cutting operational costs and increasing potential revenue and so on. Then it's also going to affect whoever comes and operate within that district. So what makes D3, if I'm going to invest this much amount of money in making it smart, what does it mean for whoever going to be working there or operating their business there? So into our business partners, our tenants, retailers or offices or so on, what does it mean to them? How can we provide information to them or provide services to them that creates value to them? Then we have whoever steps into the city. At the end of the day, Dubai is trying to become a touristic destination. We're trying to be the hub that attracts people to the city. So how does it affect these visitors' experiences? And we want to create a district and a city that is for people to come to work and live. It's not just a place that I work and then leave and then I go enjoy my life somewhere else. No, it should be a very integrated experience that they're having. And whatever experience they have in the district should also cascade back to Dubai. So we looked at the visitor element of it. And of course, the bigger value taker of this whole initiative is Dubai overall. How does Dubai benefit from this? How do we work with the different agencies? How do we work with the different partners, whether it be private or public, to create this value-added service? So we went through a killer exercise of looking at what can we bring in, And our consultant came up with a list sheet of 130 plus initiatives that we could look at across the different dimensions that I can deploy in the city and make it smart. And we're like, that's a lot. That's a lot of things that I can, and there's a lot of things are related to technology and some are not. Some are just behavior changes. Some are just like infrastructure changes, like just deploy a bike path. So we looked at it and we're like, okay, let's be realistic in the way we do things. I don't want to go and just create another propaganda of saying we're the smartest one. No, we want to be very realistic and we want to set expectation correctly and we want to get things done. And one of the things we did at the beginning, we didn't market for ourselves. We didn't say we're going to be the smartest. We were like, okay, let's get it done and then I'll talk about it. So we took that sheet and we said, okay, in the next 1 to 2 years, what do I really can focus on? What is really achievable and what are things I could test out? That is the next thing that is coming out. So we focused our efforts onto 21 initiatives, some which we are initiating at Design District and others which we are collaborating with the government agency. For example, we're collaborating with DIWA on electrical vehicle charging station, on smart meters. We're collaborating with RTA on smart bus shelters, smart buses, and so on. So we looked at this different mix of what we are working on, what other agencies are working on, what we can really achieve. So we came up with a list of 21 initiatives. And this was back in 2014. By end of 2015, we came and regrouped ourselves. We said, okay, now we've deployed a couple of initiatives. Now what do we want to do? So we started working from the smart district guidelines that Smart Dubai came up with. And then we met with our own business partners, our own retailers, and then we met with the management. And we tried to collect all of these feedbacks and understand what exactly that I'm trying to achieve, create like this strategy and roadmap of our smart initiatives. And we came up with a service catalog. So we developed a service catalog that incorporated 45 services that I want to focus on in the next 5 years as a roadmap. And when we looked at it, the good thing about it is that this gave us more focus into the different things that I can look at. And they're all listed there based on the specific criteria, whether it be a requirement from the business, making their life easier, makes money, and so on. And then what we said is, how do we prioritize them? Or how do I bucket them? Or how do I understand the value out of them? End of the day, when I do any investment, it's not just a money just thrown to just create smartness. I need to create value. I need to understand the return on investment on these things. I'm a business developer. I'm a private entity that is running a district, and I'm creating value. And it has to be an ecosystem that I'm creating that is sustainable. That is not a one-time thing that I create and then it just falls off. It has to sustain itself. So when we looked at the 45 initiatives, we were able to bucket them into 3 major buckets. A couple of initiatives were actually revenue generating. They actually can make money, like digital advertising, wayfinding, and so on. Some of them does not make money, but they can really, really reduce my operational costs, such as energy management systems, right? And then others, they don't make money or reduce costs, but they really, in the overall, either are a base for other services, for example, Wi-Fi, or they actually, at the long run, enhances the value of your property. It really increases the value of your real estate, and hence, creating more value for the district. We did another study as well, which is called Value Index. So through this value index, what we did is quantify the value from each service that we get. Quantify it in terms of the money or the saving, as well as other intangible benefits that you get out of it, such as saving time. So for example, if I'm having a visitor coming to the city, so the amount of time it takes them to find a parking, to how do they get to wherever they need to go, and so on, and how many facility managers, security guards are put in place, and so on, and then calculate the value that I get from deploying a visitor management system. So by doing so we were able to basically quantify the value I get out of it, and this also helped us into prioritizing the list of what I immediately should focus on. And we found that the top 8 services, which are listed here, are actually providing me a net present value of $98 million over the next 5 years. So we said, yes, great. Now I have more visibility of understanding where the market is going and what is the benefits that I'm getting out of it, and then have a reasoning behind why I selected this service versus this service. So this is how we did it. And to be more accurate, when we looked at the benefit, if you look at the chart there, you'll notice that the benefit that D3 is getting is 2%. We mainly looked at how the community will basically benefit out of it. Because at the end of the day, we looked at it as saying, okay, this is a smart district, okay, and it's a design district number 1. What a good opportunity we have there to use and leverage on this design thinking community to create the smart technology, or incorporate it with the smart technology and create a better experiences. And this is also the approach we're taking in deploying any of the services. The first thing that we're doing is a design thinking workshops to design the experience, design the use cases that I want to get out of these services, then go to the technology and see what is there and what is not there. So we also wanted to be very structured in the way we looked at the smart elements so that we ensure that the bases are there when we're deploying the services. I want to create a smart parking solution. What are the bases that I need there? So we looked at 3 major elements in any service that we're deploying. Number 1 is the foundation layer, the network, the sensors, the infrastructure that I'm building for it, the fiber connection, and so on. So we looked at the foundation layer that now needs to be there. Then the next level is the convergence layer, which is all of these technologies now emit data. And we hear this a lot of IoT, IoE, Internet of Things, Internet of Everything that is everywhere now. So this is what we talked about. All of this data that I'm getting from all of these sensors, how do I take them into one place that I can work with, that I can use, that I can share as well? So that's the convergence layer that we looked at. Then we looked at the transformation layer. That's taking that data, that information that I get, and make it into a context that is relevant to whatever situation or to whatever target market I'm looking at, and create a value out of it. And here where we define the different use cases or the different services that I need to build on top of it. So these are the different layers we looked at to ensure that we have it right. And we looked at different components that go across. So as I said, in the foundation layer, you have the infrastructure layer, which is the network, the sensors, the different sources of data, whether it be social media, whether it be my call center, whether it be my contracts, even to understand what is coming into the district and so on. And then the convergence layer. In this layer, we collect the data, we manage the data, but it's also important where we looked at the service layer and the API layer, because with the new law that came out from Dubai for the sharing data, the open data law, we need to be ready from now. We need to prepare ourselves to share this data at any point of time. So this API layer is very important, and we are not saying or claiming that we know everything and we're going to build everything our own. At some point of time, we're going to take that data and we'll share it so that anyone can come and build on it, whether it be services, businesses, and so on. So we want a mechanism to take that data and share it with everyone. And the good thing is that data is not isolated in a specific segment. I can have it across. I can see how parking affects facility management, affect traffic, affect visitors, affect the footfall, events, crisis management, and so on. So that's how the layer could connect everything for me and create some more intelligence and so on. And it as well creates for me a layer that allows me to create trends, or also do predictive analysis to understand what is coming so I can prepare for it, or even to verify that what I'm doing is the right thing. Then we have, of course, the layer of the transformation. And these are the different services I'm going to provide, whether it be facility management, visitor management, advertisement, seamless wayfinding, mobile application, and so on. And it's very important across these layers that I always maintain a proper governance model to ensure the standardization of everything, as well as a proper security, with everything being now, especially data being transmitted and moving across the district, inside and outside. Cybersecurity and security in general becomes really, really critical. So we always put it as a major block that goes across the different layers. Now, when we talked about the foundation layer, I'm very proud that one of the things that we've done is release or publish in the Smart City World Expo that just happened in Barcelona last month, the first of its kind ICT Master Plan Infrastructure Design Guidelines. Oof, that's a mouthful. So what is it basically? It's a document that provides developers and district owners and cities with a guidelines that tells you what different elements and infrastructure that you should consider to support the smart initiatives, how the network should be designed, how the fiber should be there, the Wi-Fi for parking, and so on. So it lists, it's not a specification per se, but it's a guidelines. And it provides also expected KPIs that you can get out of it, an ROI of it, so that you understand what needs to be done. And we actually created a subset document out of it specifically for developers, because in design district, what we'll be doing is we'll be gonna be developing majority of the land, but there is a lot of land that we'll be selling or leasing for other investors to come and develop. And we want that experience to be seamless, whether we do it or others develop on our district. So that guidelines will be given to them so that they have the basics in place from day one, so that when we want to integrate, it's seamless, it's easy. So I'm very proud that that guidelines are now ready, published, and it's even available on our website. And it looks at all elements, whether it be inside the building or outside perimeters of the building. One other thing that we've done as well so far on the convergence layer, which is the data collection layer, we've actually partnered with Cisco in deploying what they call the composite platform, and that's a data virtualization platform, which is in simple terms take a real-time dump of the data of the multiple sources that I have and provide me access to this data real-time. So we had some system already in this district available, whether it be the building management system, the facility management system is there, the smart meters from DIWA is there, our property management system where we manage our assets and contracts and so on, CRM where we manage our customer data. So these systems are already there. So we said, let's start with these systems that are existing and then try and ensure that the system that we select to virtualize the data is flexible enough to expand to other sources. And we've successfully built this, and we demonstrated it last year in December in the World IoT Forum that was organized by Cisco, and we've done a tour for it to demonstrate how this layer captured the different data, interconnected it, and created a value for me. So, for example, we host a lot of events, right? So on a 3D map, I was able to see where the different events are located. By clicking on it, I can create all the information about the event. I can understand what is the sentiment of that event from the social media feeds. I was able also to control parking management to see what is available, what is not, and if it's full, I can direct visitors to the nearest available parking. I was able to connect to my facility management to understand that, look, there is a problem here, or waste management system also connected in terms of saying, look, it's full here, so please deploy your resources. So, and in case of emergency, I can immediately deploy my resources for a quick response. So we did demonstrate a couple of use cases of how having this layer enabled us to have a better quality of service and a faster response to the visitors and better quality of outcome that is expected out of it. Then what we're doing right now and what we're working on right now is building our command and control center. So that command and control center is expected to manage all of these smart services and all of these layers of data that we're getting. So that's going to be a smart data command control center that would take that information, display it in a meaningful way on a visualization tool such as ISRI-GIS, and create these operational procedures to manage the things automatically as much as possible, and create workflows that enables us to better create efficiencies. And I'm very happy as well, and very excited as well, because we've just also expanded this command control center now, and we're going to create a technology experience center with this command control center. And this technology experience center is basically a physical way for you to go, for all our visitors, whether it be businesses or even kids, to go and understand and play around what the smart means, what are the different elements we do some sort of simulation and gaming, and increase awareness. Because we noticed that it's not just about deploying a new system. So we've deployed smart meters, right? But then it's not just that, it's also providing the information to them at the right time and then creating awareness. And we're trying to also create this awareness because it's also a culture and behavioral change as much as it's a technology advancement in the way we do things. So this is one of the things we're currently working on as well. One of the other things that I would like to also mention, that I don't have it in the slide, yes, we're trying to be very systematic in the way we do things and create structure and everything, but end of the day, we're also a trial bed. We try things, we try new technology, we encourage partners, even school kids to come, we give them the data and we try new things. We've piloted a number of projects that we, from the beginning, helped them to understand what is the value and then pilot it and giving them the infrastructure for it and then testing it out and gain feedback, live feedback from people who are already there. For example, we've piloted smart parking solution. We've piloted smart mirrors. And that was, we deployed it in the elevators so that it detects who you are and then provide advertisement information. We've also now piloting Li-Fi, which is a new technology that uses light to emit information and geolocate you and provide the information that is relevant to you. So for example, in district, we do display a number of artwork across the district. So using this light was very interesting because then when you stand in front of that art piece and the lighting that is on the artwork would emit information to your mobile device, understanding where you're geolocated, and then it sends the right information about the painting to you, right? And then maybe in the future we do it two-way. So this is some of the things we also try to test out within the district. We also have one of a unique thing or first of a kind in the region, which is 3D facial recognition. So for the building access controls, what we do is a 3D facial recognition. And why we wanted to do that is first try new technologies, and second, being in the design industry, you don't want to every time set up and then look for your card and then do something. You need to be a seamless experience. I don't need to have a gazillion things to identify me and help me do things. I need to have a simple identification method that secures my identity, allows me to do the different services I need within the district, whether it be finding a parking, accessing a building, paying something, buying something. All of this, it has to be very seamless with minimal intrusion to what you are. So it's we use you as you for your identity, or we use whatever you're accustomed to, such as mobiles, so that you'll be able to do majority of the things without addition of new items. So that's where we wanted to create the seamless experience that we wanted. So the last thing is just an example of what my command control will show me and how the different relevant information are integrated and provided. Like in the buildings here, you can see information related to environment, whether it be CO2 emission or everything, work orders, how many tenants having problems with what, or even occupancy ratings. So the sales team can actually use it to understand the occupancy and then create different strategies immediately and making decisions to attract more retailers. So that these things that we're trying to achieve is not just one way of visitors being happy, but also us as developers or salespeople. How can we make decisions faster so that we really make a value and impact there. So with that, I'm done with my presentation. I hope it was informative enough, and thank you very much.
Thanks, Hanan. Thank you very much indeed. Hanan, thank you very much indeed to you on behalf of everyone here in the arena. One more for you, and then we do our big draw of all those passports that have been completed and handed in to the desk outside. Quick reminder as well as to get yourself onto the platform. If you haven't got your passport in, last opportunity to do that. It's almost time for us to say farewell, to set you on your way. We hope it's been memorable. We hope it's been valuable. We hope it's been a great experience for you in designing the future of your making as well. And to wrap up today's themes, to bring it all together, let's get up here the head of AEC at Autodesk here in the Middle East. Man who focuses on defining the vision, if you like, for Autodesk in the building, but also the manufacturing industries, as well as cultivating and sustaining the firm's relationships with government organizations, strategic industry leaders, and professional associations across the region. An individual who, along with Autodesk, evangelizes about Autodesk as a thought leader in the Middle East and Turkey markets. Ladies and gentlemen, please welcome head of AEC Autodesk Middle East. It is Naji Atala.
Thank you. Good afternoon, everyone. I hope your day so far has been really insightful and inspirational. Let's take a quick poll. Who learned something new today? Excellent. All right. So who's learned something today that you thought yesterday was impossible? Nice. Give yourselves a round of applause. This is a really good day for you guys. Okay, so in the morning, Tony set us up, or set the scene for the day, telling us the importance of Autodesk University and how important it is for us to have it in the Middle East, because the Middle East is really a key area for the company. Then we moved with Kellen, who gave us some examples of companies who are using new technologies, such as robotics, 3D printing, augmented and virtual realities, to enable innovation and to enable collaboration. In this process, these companies are not just changing the way they're doing business, sometimes they're changing their complete industries. And it's quite interesting to see how the combination of these industries will affect our future. My favorite example from Kellen's presentation was the bionic partition by Airbus. I started my career working on the maintenance of Airbus A320, so I'm biased to that example. But Kellen showed that Airbus, by combining generative design and 3D printing, managed to shave off 30 kilograms of the weight of that partition. Now, you may say 30 kilograms is not really a big deal, but according to Airbus, if they use this methodology on the whole cabin of the plane, they save a lot of weight. A weight that is equivalent to reducing the carbon emissions from that plane by 0.5 metric tons every year. To put this into context, this means this is the equivalent of removing 100,000 cars from our roads. This is design with an impact. This, ladies and gentlemen, is what we call the future of making things. Now, then Tom delivered a very strong message. He said that these technologies are here to stay. And we either adopt them, like you've seen as Autodesk, we do adopt them in many of our internal processes, or we become another story like Kodak. Then we went to the breakout sessions where we had some presentations by Autodesk experts, and we had a lot of presentation by you guys, our user community, members of the manufacturing, of the AEC industries. And it's quite interesting for us as a company to see what you guys do with our software. Sometimes people ask me, why do we have clients presenting at Autodesk University? Why don't we get the gurus to show you how to use the software better? And the answer is quite simple. So our vision in Autodesk is to help people imagine, design, and create a better world. What we are doing as Autodesk is the help part, but the imagining, the designing, and the creating is up to you guys. We just give you great tools to do so. And we recognize that sometimes a better world is not just about productivity and efficiency. And this is why we created the Autodesk Foundation, with a charter of supporting and investing in people and organizations who are using design and making things that have a positive impact where impact is most needed. And I would invite everyone to go to autodesk.org and check some of these examples. You might be part of the change, and even if you're not part of the change, you will see some really innovative design. You will see the future of making things with a purpose. Here's an example. Kellen in the morning mentioned a Russian company called CanTouch, who've created a prosthetic 3D printed arm. So Enable has a similar design. Autodesk Foundation has helped them with the design of one of their prosthetic 3D printed hands, which is called the Raptor Reloaded. What you see behind me is people carrying this Raptor Reloaded. Their go-to-market is very simple. The designs are open source, so they encourage you to go and download these designs, 3D print the parts, assemble the hand, and donate them to people who need to do so. It's quite interesting that the material for 3D printing those parts costs around $45, and it takes around 3 hours to assemble that hand and then donate it. you may have recognized some of the faces in the slide behind me. These are my colleagues from the Dubai office. I actually used this photo without their permission. And this is after a build activity that we did for some of these prosthetic hands. These hands were donated to amputee children in a refugee and a very close by war-torn country. Again, really, I encourage you to go check out autodesk.org, see how you can be part of this change. So let's go back to what you do every day. Let's take 3 examples from the region here. The first is from SSH. SSH is a consultancy that has been playing a major role in leading the built environment and the infrastructure for the modern Middle East. What's really interesting here about being a multinational consultancy is that you need all your teams, your technical design teams and your non-technical design teams, to have access to the most recent up-to-date information wherever they are in the globe in real time. And the work that SSH is doing on the Dubai Water Canal is actually a very good example on their innovative execution. So in order to enable this execution, SSH has implemented collaboration for Revit and A360 team to have people across continents speak. So their technical design teams use collaboration for Revit to do work on models in the cloud simultaneously in real time, whether they're located in South Africa, across the GCC, or in the United Kingdom. At the same time, their non-technical design teams use A360 team to get access to this data, download it, consume it, give feedback on this data, and then deliver it to the next person in the cycle. The importance of this collaboration is not just for the project. It actually touches each and every designer who's working on a project. If I'm a designer working in one of the design teams, I now have access to processes that were before limited to another design team. So I get to share ideas with them, I get to collaborate, and in this process I get to develop my skills as well. I truly believe that enterprises like SSH would access the full potential of their people by using such technologies and allowing them to continue delivering high-quality solutions for landmark projects. Another example is from the manufacturing industry. It's by a company called Osteod. And one of the first medical designs that we had was actually the splint to heal fractures. Our earliest splints were probably pieces of wood that we found. We may have sanded them a bit to make them smooth. Now we're using cast, but the concept is still very similar. You immobilize the cast and you wait for it to heal. I've had the pleasure to meet Mr. Dennis from the middle picture behind me. And Mr. Dennis used a tool called Fusion 360, which is the first born-in-the-cloud design, simulation, and manufacturing tool to collaborate with a renowned university in the region and come up with his design. So now you scan your arm and you use a 3D printer to get this new type of splint that fits your arm exactly. Advantages are it's much lighter, it's resistant to elements, and it's removable. More importantly, it is not a passive device, it's an active device. So on the top arm, on the top side of the splint, there's a device that emits low-intensity ultrasounds. And an exposure of 20 minutes a day to these ultrasounds promises to reduce the healing process by up to 40%. My third example comes from Bureau Happold, who are in the business of making visions viable. Bureau Happold is the consultant on the Museum of the Future, which you see behind me here. Now, the Museum of the Future will stand really close by, and it's a very complicated structure. The outer steel cladding will actually feature Arabic poetry by His Highness Sheikh Mohammed bin Rashid Al Maktoum. When doing the design, Bureau Habold had to manage 3 high-level parameters. First is the number of nodes in the structure. So how many connections would that structure have? And this directly affects the cost of building that structure. Second is the material used and the structure. The weight would also affect the cost of that structure. And third is how much you can get, or you can remain close to the design intent by the architect. So Bureau Habold used a tool called Dynamo, which adds visual scripting powers to Revit, where you can connect these 3 parameters and check out the outcomes. And by playing around with the parameters, they hit the sweet spot, what they saw as the optimal design. And this design had a 40% reduction in the number of nodes, 30% reduction in weight, and decreased the variation from the architect's intent by up to 80%. So with all these changes in the industry, we will continue to give you newer tools to do your work better. We will still add functionality to the tools that you have, and we are shifting our business model to actually accommodate the new way of doing things. So the 1st of August was actually a milestone for us, where we've stopped the sales of all perpetual licenses and moved to a completely subscription-based model. And then we announced suites, which replaced our, we've announced collections, which replaced our suites. I have to confess that earlier it was sometimes confusing to know exactly what you needed out of our solutions, but we've moved from more than 20 suites into 3 collections that promise that you have access to the right software from the industry that you operate. These collections, as you probably know by now from the partners that you're dealing with, are available in subscriptions of a month, a quarter, or a year. And a point to emphasize is that they are not repackaged suites. So we meant those, we designed those to be extensible, and they already have a lot more functionality to enable your businesses than Suite did with all the cloud access that you get. At the end, I hope you're as excited about the future as we are. I really want to thank you for sharing the day with us, and I hope to see you all at Autodesk University Middle East 2017. Thank you.
Thank you. Bless you. Thanks so much indeed to you. And thanks to all the team from Autodesk. That is almost it from us. Do hope that you have experienced the future of making, of things, of reality, of making things become reality. And do hope you filled in your passports. And I've been banging on about them all day long. But this is the moment when we reveal who today's winners are. We've got 2 Microsoft Surface Pro 4 tablets. So if you have filled in your passports, you are in the offing to possibly get your hands onto those. And whilst it's almost time to unveil our prize winners, we would ask you please to open up those Autodesk University mobile apps for one final time. If you've got your devices on you, your smartphones, can I just ask you to open up the app one final time? Reason being, it's going to take us a few moments just to get things set up here with the tombola for the final draw. And if you could please fill in the survey for us, just 2 minutes of your time. It enables us to build bigger and better for next year's university. It's all it takes is a couple of minutes of your time round about now, just as we're getting bits and pieces into place for the final draw of the evening. Give us your thoughts today. We can make these experiences even bigger, even better for next year. So we give you 2 minutes to do that, and then we draw our winners. Just no, I know it can be a little bit of a chore, but it just really helps us in building a bit of feedback that we can take on and make your experiences better for next year. So I'll just allow you to conclude with that. In the meantime as well, we have been joined on stage by all of the filled out passports. What we will do once we draw the winner, if the winner is still with us here, we'll ask them to come validate their number on their passport with the corresponding ticket down here. And then, of course, there will be a quick presentation of the prize outside as well. But we'd ask you please to come and validate that. Okay, if you have finished filling in your surveys, the girls are here with us to give it, please, one final swizzle, if that's all right, girls, to put that all the tickets into the mix. Swizzle, an official word? I'm not sure if it is, but there we go. So we have the magic key as well. And I'm not looking at all any of those. We're going to dive straight in and select the first of our two winners. And the first of the two winners to win that Microsoft Surface Pro 4 outside is Ziad Kadar of CCC. Ziad, are you here? First of our winners, so well done to Ziad. Here's the first of the winners. I will give you your passport back, and thank you very much indeed. The team will meet you down there, and we'll make sure that the prize gets to you, so thank you to you, Ziad. Time now for one of the other winners, and time to dive in. Who's it to be? Who's it to be? Who's it to be? Let's have a look. The winner is... Oh dear, it's from CAD Emirates. The winner is Edwin Mendoza. Edwin, are you with us? Edwin, now I know what everyone's thinking. They're saying redraw, 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 but there are rules, all right? And we do have Edwin's details here, so we will verify those details with Edwin, and in keeping with the policies of the building in which we're in, then of course we will make sure that he gets those details. There we go. They go down to the team there. Listen, thank you very much indeed to all of you for all your input throughout the day. Do fill in those feedback forms if you can via the app. It's very much appreciated from us. If you haven't done so already, there's a little thank you from us to you, a delegate gift on your way out. If you haven't picked it up already, just pick it up on the way out to the exit. On behalf of all the team down here at Autodesk University, hope it's been beneficial for you for the first time ever here in the Middle East. To all the speakers, we thank you for your time. To all the delegates, we thank you for your time. And for those with the blue lanyard, we'll see you outside. Do stay around for a little more networking and, of course, a few delicacies out there in the pre-function area. But for now, thanks for joining us. So hopefully we'll see you again in 2017. Till then, bye-bye.